we have the revision session sometime, and then Shrikant will be taking a revision session. Okay.
Can you please repeat your voices?
Your voice is breaking a little bit, ma'am.
Yeah, can you please repeat?
Am I audible?
Your voice is breaking, ma'am.
Am I audible?
Yes, ma'am, you are audible.
Now you're
Okay.
audible.
Okay.
Yes.
So
Again, there is a
we'll
disturbance.
I
start
think, ma'am,
from week
you are
4
having
the
some
session.
internet issue.
Okay. Just give me a minute then. Am I audible now?
Yeah, ma'am.
Yes, lot
Yes,
better,
ma'am.
madam.
Yeah, ma'am.
Okay, yeah.
Yes, ma'am. You're audible.
Okay, so we'll start first with week 4 topics. Okay. So in week 4, we have these topics that I have listed it here. So
Hello,
yes.
ma'am. What are you discussing? Week 4?
So week
Topics?
4 we will discussing
Okay.
like
Yeah,
now.
the-
So we'll
The week,
start. Yeah.
so you are starting from week 4.
Yeah, I'm starting from week 4, and then
Okay.
other instructor Shrikant will be joining the session and they will be taking the continue.
Okay.
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 So we have these topics in week 4. So one is like CDF, then PDF, we have PDF, and then some common distribution. Okay, so let's start with the CDF first. So a CDF function is defined as, like, if you have any random variable x, the CDF function we defined using fx of x, capital Fx of x, which is nothing but probability that your random variable x taking the value less than equal to small x. This is how we define the CDF as, and basically this CDF is nothing but a function from your real line to 0, 1. Okay. So this is how we define the CDF of a random variable. There are various property of CDF that it should hold.
Document?
This document, yes, I can put it on discourse. This is not finalized. So I will put it on discourse. You can check it there.
Not in the supplementary contents. Huh?
Sorry.
Not in the supplementary contents.
No, not yet. It is not finalized, so we haven't put it.
Okay.
Yeah.
All right. Thank you.
So, yeah. So this is how we define the CDF as. Now, there are few properties that the CDF should satisfy. So the first property that it should satisfy is CDF should be non-decreasing function. Okay. So basically the CDF should be increasing. That is the first property. And as your x approaches to minus infinity, so let's say if you have this minus infinity, as the x values approaches to minus infinity, the CDF should go towards 0. And as the x value approaches towards infinity, the CDF should go to 1. So as you can see in this graph over here, we have a CDF. This is a graph of plot of a CDF. You can see that this is a increasing function, right? So for x less than 0, it is 0. For x lying between 0 to 1, it has some probability. Let's say here it is 0.4. And for x greater than 1, it is going towards 1. So as x tending to minus infinity, basically the CDF is going towards 0. And as x approaches to infinity, the CDF goes to 1. So these three properties you should, the CDF should hold. And one more property that we have for CDF is, like, if you take any point, any 2 point on a random variable of a random variable. So let's say if you have a random variable x and you want to find what is the probability that your x lies between some a and b. Okay, so this we define using CDF as fx of p minus fx of a. So this is also very important to remember. You can also derive this if you want. So you'll just have to use the definition.
I'm sorry to interrupt. Is it strictly between A and B?
Okay, so a and b is any two values that a random variable is taking, right? So let's say if x is taking the value in 2 to 4, or let's say 2 to 10. Okay, so probability that x lies between some 8 to, let's say, 5.5. Okay. So in this case, it is a continuous. Let's say this is a continuous random variable. So probability that your x lies between some 5.5 to 8, this will be same as writing that fx of 8 minus fx of 5.5.
Okay.
So what is fx of 8? It is probability that your x taking the value less than equal to 8. And fx of 5.5 is probability that your x is taking the value less than equal to 5.5. So once you, like if you plot this on a real line, see here. So say this is your 5.5, so this is your 8. Now probability that x is less than equal to 8. So x is less than equal to 8 is this side. And if you subtract x less than equal to 5.5, right? If you remove this part, then you will get probability that then this x lies between 5.5 to 8. So you should keep this property in mind because it comes very handy when solving the problems. So these are the 4 properties that a CDF follows. Then we have some examples over here. So the first example we have for the binomial random variable. Now, if you have a binomial random variable, you know that it takes just 2 values. One should be success, another should be failure, right? So success and failure, where we denote success as 1 and failure as 0. And we denote probability of success by P and probability of failure as 1 minus P. Now, if we have to plot the CDF, right? So since x is a discrete random variable, let's see it here. Okay. So this is your fx of x and this is your x. Now, since x takes only 2 values, 0 and 1, and our fx is defined as it is a function from real line to 0, 1. So let's say this is your 0 and here it is 1. Now for any x that is less than 1, okay, less than 0, your CDF is going to be 0.
0. Yeah.
0, right? Now for any x that lies between 0 to 1, so we have, it is a discrete random variable. So either it can take, the random variable can take either this value 0 or it can take the value 1. So if I'm saying that x lies between 0 to 1, it means this is nothing but fx of
At 1.
sorry, you're saying something?
No, ma'am.
Okay. So okay, so probability that your x lies between 0 to 1, right? So this will be just probability of x equals to 0. So what is the probability of x equals to 0?
Probability of x less than 0 minus probability of x greater than 1.
Probability of x
Less than 0 minus probability of x greater than 1.
X greater than 1. What is this?
And CDF. Yeah.
Why
Probability
is
of
this CDF?
I mean, my probability of x from 0 to 1.
Okay, so we have to find the probability that x lies between 0 to 1, right? 0 is inclusive and 1 is exclusive. So since x is taking just 2 values, it means it is just probability x equals to 0, right? And what is probability x equal to 0? It is 1 minus p. So
Yeah.
this point over here is 1 minus p. Okay. And as x is greater than equal to 1, So probability that x is greater than equal to 1. So this is, okay, sorry. We have to find fx at x greater than equal to 1, right? So fx of x where x is greater than equal to 1. Now, if you find fx of 1, fx at 1, how will you write this? This is probability x less than equal to
1 minus 1 plus p means fx means probability of x greater than
1.
equal to 1 minus probability that x is between 0 and 1, 1 not inclusive, minus. If we have to find out fx of 1.
Yes. Yes. So this becomes just no, this should come out to be 1, right?
No, it will come out p.
It is probability of 0 plus probability of 1.
And it will be 1
Yes.
minus 0.
It will be 1 minus p.
We are adding here. CDF.
So if you're finding the CDF, then you will have to add the previous probabilities.
Yes.
1 minus
So
p
you will
plus p.
have to do 1 minus p plus p, and that will come out to be 1. Right?
No,
So,
didn't get, ma'am. Didn't get this
okay.
one.
Ma'am, it will
How
be
it is-
P.
Ma'am, it's
Ma'am, if we have to
FX
calculate
of 1 I am talking about.
It's 1.
yes, ma'am.
Your voice is
CDF,
not clear.
PMF. Yes.
Hello.
CDF it is 1.
Yeah, please tell.
Yeah, ma'am. So how it is getting 1
Your voice
at
is
point 1?
not clear.
Hello.
Yeah.
Yeah.
Hello.
Yes, ma'am.
Yeah, please go on.
Yeah. So I was saying that how it is coming as 1 fx of 1.
Okay, so in CDF, what do we do? In CDF, what do we do? Like here, x was taking the value 0, 1, right? X
Yes.
is discrete random variable, just takes 2 values. Now, if we have to find the CDF of this random variable, what we do, so for x less than 0, we just put it is 0, because as x approaches to minus infinity, your fx should approach to 0, correct? And as x approaches to infinity, your fx should approach to 1. So in this case, if x is greater than equal to 1, it should approach to 1, right? So what is left is x lying between 0 to 1.
0 to 1. 1 minus p.
So probability that x is lying between 0 to 1. So in this case, it is a discrete random variable and it takes just the value 0, discrete point 0. So that probability is 1 minus p.
Okay.
Now, if we had to find probability like fx of 1, okay, so fx of 1 will be what? So you will have to add the previous probabilities also, correct? So it is probability x less than equal to 1. And since x is taking 2 values, that is 0 and 1, it is going to be probability x equal to 0 plus probability x equal to 1. What is probability x equal to 0? It is 1 minus p, and this is p. So this becomes 1.
It's equal to 0, it is 0, no?
Probability, this is a discrete random variable we're
Yes,
talking about.
yes, yes, yes.
So it is 1 minus p,
Yes, yes, yes.
right? So we have to like the
Yes, yes,
the
yes.
CDF. Okay, so in case of discrete random variable, if you have a discrete random variable, CDF in that case will have a jump like structure. So as you see in this figure over here, right? So this CDF has a jump at 2, at 0 it has a jump, at 1 it has a jump. And how do we find, like in this case this is a graph for CDF, but in case if we have to find out what is the probability of x equal to 0, if we have to find from here what is the probability that x equal to 0, so we will look at how much jump it is there at 0. So this distance is 0.4. Okay, so this is simply right. It is this is 0.4. Now, if we have to find the probability x equal to 1, so we'll look at the jump that 1 has. So this is overall 1 minus 0.4, that becomes 0.6. So probability of 1 is 0.6. So in case of a discrete random variable, if the CDF is given to us, we can find the PMF by looking at the graph, like how much the jump is there, we can find the PMF. Okay.
The jump is the PMF, is it, ma'am?
Yeah, how much the jump is, like that becomes the PMF.
Ma'am, here one thing. Since you have mentioned this is discrete random variable, so it is obvious, like in the question, it won't be asked. Okay, tell the probability of between 1.5. I mean 0.5 to 1.5, like that.
Okay, so you are saying if it is a discrete random variable, it won't be asked how to find probability 1.5 to 5.5, is it?
Say 0.5 to 1.5 also, like, I mean, in interval actually.
Okay.
See, as here in the graph, can you just scroll up, man? Here.
Okay.
So at the x equal to 0, it will have a jump of 0.4. Okay, so we can say the probability is 0.4 for here, and at the 1, it attains the value of 1 or whatever value here. Okay, so if we are asked, okay, what is the probability between 0.5 to 1.5?
Okay, so 0.5 to, so are this point inclusive, exclusive?
Yeah, you can
okay,
take
let's say this is this. Okay,
yeah, normal.
So
only.
x takes, in this case, x takes is 2 values. It is either 0 or 1. So I can say in this interval 0.5 to 1.5, I will have just 1 point, that is 1. So I can just simply write probability x equal to 1. And what is probability x equal to 1? It is just 1 is success. So this will be just P, probability of success.
Okay. Yeah.
Okay. So in case of discrete, you will have to take care of this.
Ma'am, you don't have a jump both in 0.5 and 1.5.
Sorry?
You don't have any jump in 0.5 and at 1.5.
No, we don't have.
So how do you say that the probability is 1 then?
So probability that x lies between 0.5 to 1.5. Okay, we have some example also. Let's go over there. Okay, I think this is a good example. This was done in the lecture. So this whole thing was from the lecture. Okay. Now, in this case, we have considered x to be a discrete random variable, which is uniform in 1 to 100, right? And in case of uniform random variable, we know the CDF is given by, so for x less than 0, it becomes 0. And for x lying between k to k plus 1. So k here lies between 1 to 99. Okay. So in that case, we have defined our CDF to be k by 100. And for x greater than equal to 100, we have defined it to be 1. Now, the first question, if you look over here, it says find the probability that x lies between 3 to 10. So we know that x is taking just the discrete values. So it is your 1, 2, 3, and it will go to 100. Okay. Now, probability that x lies between 3 to 10. So this is going to be using the properties of CDF. This is going to be what? This is fx of 10 minus fx of 3. Correct? Fx of 10, we know from the definition here. From the definition of fx, we know what is fx of 10. And it is 10 by 100. And similarly, fx of 3, using the definition here, we know this is 3 by 100. So we can find it is 7 by 100. Now, what about if x lies between 3.2? So initially it was 3 to 10. What is the probability that x lies between 3 to 10? Now it is what is the probability that your x lies between 3.2 to 10.6, right? So using the CDF property, what we will write? We will write this is fx of 10.6 minus fx of 3.2, right? So fx of 10.6 is what? Fx of 10.6 is what? This is nothing but probability x is less than equal to 10.6, correct? And we know that x takes discrete values. So it will be probability x equal to 0 plus probability. Okay, wait. So we don't have to do it here. So we have to find probability x less than equal to 10.6. And we know that x doesn't take the value 10.6. So it will take the value probability x less
We can
than
do
equal to
11,
10.
ma'am.
Sorry,
Can't we do 11?
why should we do 11?
Because I think 10.6 is more than 10. So I thought.
No, it's not about that. So 10.6 is here, right? Let's say this is our 11.
Ma'am, but
So
there's a problem with the 3.2, ma'am, in that case.
okay, so 3.2 is what? Fx of 3.2. We know that this is going to be probability x less than equal to 3.2, correct? And we know that x doesn't take the value 3.2. So x should take the value which is less than 3.2. It means it can take maximum till 3. So probability x less than equal to 3, we can write it.
Ma'am, here the conflict came with the last statement what we have asked. So what I was assuming, okay, because this is a discrete random variable, right? So we will be considering the probability of the discrete number. So
probabilities of the discrete number, right?
It's a 3.2. That is more than 3. So we're going to consider all the discrete variable, discrete numbers.
All the discrete,
okay? Yeah. So, but more than 3.2 is a number is actually 4, ma'am. The next number comes as a 4 actually, not the 3, ma'am. That's what my last.
3.2 is actually not
Yes, exactly. Exactly. The last question what I have asked, okay.
So the probability of it taking the value 3.2 is 0, right?
I'm just relating with my previous question, ma'am. I have asked you.
Okay. So you had asked, let's draw here. So 0.
I don't want to consume much time here. So I just want to.
So it was, I think, something here, 0.4 and okay, let's go back. All right. So the question was, what is the probability that x lies between
0.5 to 1.5, ma'am.
0.5 to 1.5.
Yes.
Right.
So here
we know that x takes just 2 values, correct? Now this is going to be fx of 1.5 minus fx of 0.5, correct?
Yes, ma'am.
And according to definition of CDF, we know this is probability x less than equal to 1.5.
Exactly.
And this is probability that x is less than equal to 0.5.
Yes.
Correct.
Yes,
so we'll have to, so 1 minus 0. Correct. This is going to be just 1.
Okay.
Okay, so this is what you will get if you have to find probability x lying between 0.5 to 1.5.
I don't got how you written 0, like
why we have written 0 where?
Probability of x less than 0.5. It should be, I think, 0.4.
Yeah, that's what I was also thinking.
3.4, right?
There is no change for probability 0, no. There's no jump. So 0.5 is there's no jump. So probability 0.
Yeah. X less
where are you talking about 0? Where are you talking about 0?
The recent line
one?
that you wrote.
Okay.
Yes, ma'am. In that line, you wrote, you had written 1 minus 0.
Okay.
Okay,
wait. I wrote. Okay. So this is nothing but probability x going to be 0 plus probability x equal to 1, right? And this is probability x equal to 0. So this becomes just probability x equal to 1. Is it all right?
No, ma'am.
No?
But you said
ma'am, I mean that the probability of x less than equals to 1.5 is 1.
Let's
Yeah.
write it
Yes,
somewhere
Probability of
else.
x less than equals to 0.5 is 0.4.
Probability that wait, can you repeat? Probability of
X less than equals to 0.5
huh?
is 0.4.
Why do you want to take 0.4? X doesn't take, X takes just two values, right?
Yes, ma'am.
Yeah, but
X takes just two values, 0 and 1. These two just discrete point.
Oh.
So
Okay,
it cannot take, X cannot take the value 0.4 either.
Okay,
So
ma'am.
X will only take the value 0. So that is why we have written this is nothing but probability X equal to 0. And why probability X less than equal to 1.5? So we know X is not going to take any decimal value, right? So below like numbers which are less than 1.5, it is 0 and 1 that X is taking. So we will have to write probability X equal to 0 plus probability X equal to 1.
Okay, ma'am. I got it.
You got it?
Yeah. Actually, I was
So
looking
you
on
have to
the
be very
probability
careful
of-
y-axis.
here.
Hello,
Actually, I was looking on the y-axis.
hello.
Yes.
Probability of x equal to 0 is 0.4, na ma'am.
In this case, it is 0.4. I'm not talking about what the values are here in general.
No, are you really referring
Probability
to the
of
chart?
1.5 is 1.
Probability of 1.5 is 1.
Less
Yes, it is 1. Because you'll have to add both. Sorry, probability of X equal to 1.5, we said.
Ma'am, are we referring to this chart or not?
Hello.
Which chart? This
0.6, na
this
ma'am.
graph.
This one, the 0.4 and 1. The chart what
Okay.
you're showing.
They mean
Okay.
Hello,
this
ma'am.
graph, ma'am.
Hello.
And
Okay,
if
okay.
you take reference to the chart, then
Yeah.
0.5 and 1.5, the probability is 0.6 only. Is that right? Because probability 1 minus probability 0.5 is
Yeah, that's what I had
1
written
minus
here, right?
0.4 is
It
0.6.
is nothing but probability X equal to 1. So probability X equal to 1 is 0.6 only.
PNF is 0.6 and cumulative will be 1. That's what she's trying to say.
Okay, I'll just repeat the same thing again, and after that we'll move.
Hello.
Yeah.
Actually, ma'am, when we did the this type of question, there's a concept where at any point there's no jump, the probability should be 0. So it will help, ma'am.
It won't help actually. That is for the, when you want to find the value at the particular point. So in that case, the value will be 0 actually. But
Actually,
when we asking for the interval actually, it won't be 0.
There's no interval, it's a discrete value. So when we
These are discrete
resolve,
values.
so it's become for a particular point like 1.5.
Wait, I will write the
0.5.
same thing again here. So I will refer the same graph that we have. Okay. We have X to be Bernoulli random variable, which takes two values, two discrete points, 0 and 1. In this case, probability that X takes the value 0 comes out to be 0.4, and probability that X takes the value 1 comes out to be 0.6. Okay. We are interested in finding what is the probability that X lies between 1.5 to 0.5. All right. So using the CDF property, we can write this as fx of 1.5 minus fx of 0.5. Correct. And what is fx of 1.5? This is nothing but probability that X takes the value less than equal to 1.5, and fx of 0.5 becomes probability that X takes the value less than equal to 0.5. Now, since X is a discrete random variable and it takes just two values, 0 and 1. So if I am writing that X is less than equal to 1.5, so X can take both the values, either 0 or 1. So for this, we will have to add both the probabilities. In this case, probability can be either X equal to 0 or X equal to 1. It means this is probability X equal to 0 plus probability X equal to 1. Now, when we write X is less than equal to 0.5. So in this case, we have just one value that your random variable X is taking, that is 0.0. So we will have to subtract this probability x equal to 0 from here. So once you do it, you will get probability x equal to 1. And from here, we know that this comes out to be 0.6. Is this okay? Is this clear now? This
Yes,
part?
ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am. It's
Clear, ma'am. This is right.
This is clear?
yes,
Yes,
ma'am.
ma'am.
Yes,
Please
ma'am.
move
Now
ahead,
also
ma'am.
if you don't use the CDF, you can see that you are interested in x taking the value 0.5 to 1.5. Can you mute? Okay, so if you want to not look it through the CDF, we can also find it using the PMF, right? So this is a discrete random variable and x lies between 0.5 to 1.5. Now between 0.5 to 1.5, we have just one value, that is 1. So this is going to be same as probability x equal to 1, and this is 0.6. So very straightforward this is. So you can decide what do you want to use.
It's good.
Okay, so we'll move
Yes, ma'am. Yes.
we'll move to some other part. All right, so this example, you can just have a look. It's the same what we have just discussed,
Yes.
right?
And this is a PDF version of PPT, right? Whatever PPT we are getting is a PDF version of that only, right?
Yeah,
This
something
document.
more detailed. Yeah.
Okay.
Okay, now we'll talk about the continuous random variable. So in case of discrete random variable, we had seen that the CDF had jumps, right? At each of the discrete point, the CDF had jump. But if the CDF is continuous, if the CDF is a continuous curve, like something like this, you can see there is no break in the graph. There is no jump. It's all continuous line, right? Continuous line. So we are saying this CDF is continuous. Once a CDF is continuous, you will have a random variable for which this is a CDF, and we will say that random variable is a continuous random variable. If you see any CDF to be continuous, you will say the random variable is continuous. So the first graph that you see over here, this is again the curve is kind of straight and it has a line. Okay, so the first example is for the continuous random variable. Now, if you look at the second graph over here, this is also the plot for the CDF, and you can see it has jumps at all this discrete point, correct? So once you see a CDF like this, you will say it will have a, this is a CDF for a discrete random variable. So we'll say this is for the discrete random variable. Now, this case here, you see that at 0, you have a jump of 0.5. But after this 0.5, you have a continuous curve. So such kind of distribution, if you see, so this kind of distribution is called as mixed distribution. And again, this fourth curve over here, this has a continuous curve, curve. So this is again a continuous random variable. We had seen the properties of CDF, but in case of continuous random variable, like if you have to find probability x lying between A to B, you will say this is same as probability that your x lies between A exclusive and B inclusive. Okay, you are taking B here but not taking A here, and this is also same as probability that x takes x lies between a, where a is inclusive, and x is less than b. And this is again same as probability that x takes the value a and b. But this is not the case in case of discrete random variable. When you have a discrete random variable, all these probabilities will come out to be different. So this is one thing that you should take care of, because in continuous case, at any point, probability that x equal to a comes out to be 0. Right?
Yes, ma'am.
Yeah. All right. So this was all about the CDF. So once you look at the graph, or you come across any CDF, you try to plot the curve first. And once you plot the curve, it will be easier for you to see how are the values, like how the graph look like, and whether it is a continuous or a discrete random variable. And in case it is a discrete random variable, if you plot the CDF, it will be easier to calculate each of the individual probabilities, like at each point, what value does it take. Okay, so plotting the graph is a good way to solve the problems from PDF and CDF, sorry, CDF. Then after the CDF, we have something called probability density function. So any continuous random variable x, okay, if you have, in case of discrete random variable, for any random variable x, we have something called PMF, right? So what was PMF? It was called as probability mass function, right? It was called as probability mass function, and it gives the probability that each of the that the random variable takes at each point. So at x equal to small x, what is the probability? That is what the PMF gives basically at each of the point that your random variable take. But in case of continuous random variable, we know that at each of the point, let's say if x is a continuous random variable and some x naught belongs to x, then probability at this point x naught, or any point x naught that belongs to this random variable, comes out to be 0. So if you want to, we cannot have something called PMF. We in this case, we are introducing the density function that we call as PDF, and the PDF is defined as like any continuous random variable x with CDF fx is said to have a PDF if for any x naught, fx of x naught is integral minus infinity to x naught, small fx of x naught. So this function that you see over here, right, this fx of x naught, this is your PDF. This is your PDF function.
So effectively, it is
What
the
was
integration
PMF?
of a continuous PMF. Let me put it as for want of a better word.
Okay.
It is like a continuous function. You are trying to find the area under the curve. Is that
area
correct?
under the curve, yes.
So if it were to be discrete, I call it MF. If it is continuous, I call it DF.
You call it as PDF.
Okay. Essentially, that's the difference, right? That's all right.
Yeah.
Okay.
Because we cannot have a concept of probability at a single point in case of continuous random variable. So we talk about the density.
Okay. But one question I want to ask, why is it so significant PDF? Because you one of the other classes, it was mentioned that PDF at a particular value is always 0. So why do we really
in case
need to
of
worry
continuous in case of continuous random variable? Yeah, so here we have a few points that we have listed. So why do we need PDF when we already have a CDF, right? So
yeah, but especially when PDF is at any value, if I take it, it is a 0, then what do I need it for actually? When do I use it? Let me ask.
Okay,
ask
so
that. Yeah.
okay, so PDF what happens in CDF is like CDF is just a function from your real line to 0, 1, correct? But it does not give a clear picture of how your distribution looks like. But if you plot the CDF, you can look at the histogram and you can identify like what kind of curve it is, you can identify distribution. So some cases like this PDF, the concept of PDF helps in finding out the distributions. But in case of CDF, it is very difficult. So that is why we need to have we have a something called PDF.
Only for identifying the kind of distribution it is.
Like this is one just
use.
one
Okay.
One benefit. And okay, PDF is also much easier in probability computation. So sometime not always I would say, but many a times calculating PDF is much easier. And once you know the PDF, and if you want to find the CDF, you can always integrate and find it out. So PDF, if you integrate the PDF, so let's say I want to find the probability that X lies between some interval A to B, okay? Now, if you want to find this probability and you know that X is a continuous random variable, okay? If X is a continuous random variable and let's say it has a CDF fx of X and PDF small fx of X, this is nothing but to find the probability. We have two different methods. One thing is either you can integrate the PDF, that is fx of X dx from A to B, or you can write this as fx of P minus fx of A. So if the PDF is known, like if the CDF, let's say the CDF is not known, then it's like both ways. Sometimes one way is easier, other way is easier.
Okay.
Yeah.
Ma'am, I think
And what about
PDF
PMF?
gives more precise picture of distribution.
Sorry.
I think a PDF gives more precise.
Yeah, that
precise
that
distribution.
we already talked about.
That's what
Yeah.
point,
And what
that's
about
what
PMF?
point number 3 talks about. Point number three.
This is point number 3, and
Yes,
okay, point number 4 is basically some yes, like if you know the distribution, then using the CDF it is much easier to calculate. But if you don't know, then PDF comes more handy in that case.
And
So
PMF?
a PMF, you're not talking about PMF here, right? This PMF
What?
is for a discrete random variable.
Okay.
Madam, in some of the problems that are there, the PDF is written as P belongs to brackets 0, 1 by 4. I'm talking about the activity, tutorial questions. What does it actually mean? P belongs to 0, 1 by 4.
P belongs to 0, 1 by 4.
Yeah.
Okay. P.
Are those
Okay,
curly
not this.
brackets?
P belongs to brackets and then
Okay,
0,
okay.
1 by 4.
Maybe that is a limit, upper or lower.
Yeah,
I
0,
mean,
1 by
Something
4.
like this.
Yes. What does it mean?
Okay, so this basically is what is the probability that your X lies between 1 by 4
by 4 and 0.
to 0.
And 0. Okay, those
Yeah.
are the limits then.
Yeah.
Okay, so the function should be somewhere and I need to substitute these values in the function and calculate.
Yes.
Okay.
Ma'am?
Ma'am, if it is given square bracket in both cases, then we have to take the
If yeah, like if it is a continuous random variable, then you find this or this doesn't matter. It gives you the same result.
Okay.
Ma'am?
Yeah.
Like in case of discrete random variable, we have PMF, right? And
Yeah.
we sum them and we get CDF, right?
Yes.
In case of continuous distribution, we have PDF, probability density function. It is not
Yeah,
the
you have
probability, but
PDF. Yeah.
probability density, right? So we are in place of summing up, we are integrating. It, right?
In place of
And-
summing, we are integrating.
And we are getting CDF, right?
Yes.
So how this integrating is converting, because when I am adding something, the unit will remain same. Like I'm adding probability density, so ultimately my result will be probability density only. No? So how this probability density is getting converted into probability? Because density, as we know that it is a ratio.
Okay, so fx. Okay,
Yeah.
so you have a CD of fx. Okay, and if you are finding at some point x naught, using definition, we know this is fx of x naught dx, where this is lies from minus infinity to x naught. Now you want to.
Hello.
Yeah, just hold on.
I'm saying that on integrating, it means I'm summing it up, right? So when I'm summing it up, then how probability density is getting converted into probability? Because when I'm adding two quantities, so the unit remains the same, right? So here when I am adding probability densities, so from density now I'm getting probability. Will it not be probability density again? Because like density, what we know, it's a ratio of two things, right?
Yeah.
So say for example, we are saying density is equal to mass by volume. So mass is nothing but volume into density. So we are multiplying these two products, right? So here, how summing it up, how through summing it up, integrating, my probability density is getting converted into probability.
Yeah, so I think the last like session I told, like once the course is over, we can have a proper visualization on this topic, right? PDF, CDF. I think you had only asked last time.
This question I have not asked.
Yeah, like how this PDF looks like. How do we get CDF from there?
That I had asked that about the derivation of PDF, that how we are deriving PDF, right?
Yeah,
okay,
right.
Okay, this also we can discuss later on.
Yeah, so let's not, this like this is a written session, right? So let's not go.
I asked for that purpose.
Yeah.
Madam, just one more question on the earlier one that I asked. Brackets, if they are normal brackets, it's open interval, and if it is square brackets, it's closed interval, is it?
Yeah, closed bracket is, this is closed interval. Square bracket, sorry. And this round bracket is open interval.
So closed bracket would mean less than or equal to or greater than or equal to.
Yes, and small bracket is less than and less than greater than.
Strictly less, strictly.
Yeah.
But does it matter in the continuous distribution, madam?
No, it doesn't matter in the continuous random variable.
Okay.
Okay, so there are a few of the properties of PDF. So it says PDF is a function from R to R, and there are three properties. The first one is your fx should be greater than equal to 0 because it's a density function. Second is integral of fx from minus infinity to infinity should be equal to 1, and fx should be piecewise continuous. So we'll not look at this part for now. So basically these three properties should be satisfied in order to have a density function. Now, if you have some PDF function given to you, okay, like okay, let's say this case, I am saying this fx is a PDF of the random variable x, but in this case our k is unknown. Like probability that x lies between 1 to 4 is k, probability x lies between 1 by 4 to 3 by 4 is 2k. So we don't know the actual densities. So how do we find that? So we will have to integrate, right? So we know the fx, the properties of PDF, that if you integrate fx from minus infinity to infinity, it should give the value 1. Correct. So if you integrate over all the intervals, so in this case, I will do minus infinity to 0, then 0 to 1 by 4, then 1 by 4 to 3 by 4, and then 3 by 4 to 1, and 1 to infinity. So all this should sum up to 1. And once you solve this, you should get the value of k. And for that value of k, your fx becomes a valid density function. So this is something that you should know how to find. Okay. Now you have something called support of a random variable. So what is the support of a random variable? So if you have a random variable x with the density fx of x, then support of x is given by like any x that x takes, fx of x should be greater than 0. So basically support of x takes all those value of the random variable for which the density function becomes greater than 0. Like look at this function over here. It says fx is 3x squared where x lies between 0 to 1. Now what should be the support for x here?
0, 1, where 0 and 1 are not included.
Yeah, because for any x that lies between 0 to 1, you can see that your fx is greater than 0. So this is going to be your support. Right?
Can you repeat
Yes.
this support once, ma'am?
Support is like all those values that your random variable take for which the density function is greater than 0. Right? So density function is fx of x greater than 0. Now if you look at this example over here, okay, so for if I want to find the support of x, it means we need to find all such x for which fx is greater than 0. So what all the points are there for which fx is greater than 0?
0 and 1, I think.
Between 0 and 1, right? So this is nothing but support of x.
Ma'am,
Ma'am, I
it means
wanted
all
to
the
ask
random
that.
variable is greater than 0.
Sorry?
It means all the random variable that is greater than 0.
No, all those values that the random variable takes such that the density function is greater than 0.
It's a range now, simply.
Not the random variable greater than 0, the density function for that value that the random variable takes, that should be greater than 0.
Ma'am, what if it is written as x is greater than equal to 0 but less than 1? Then also we'll take simple brackets, or we'll have
So
to take
okay,
square
so
bracket only?
if you write 3x square for, in this case, if you, this is a continuous random variable, we know that, right? So if you add 0 in the support, but at 0 your fx is going to be 0 because it is a continuous random variable. So we'll just write the support is 0, 1. Okay. Now let's move to some.
Is it the case
But
always
it's
that
got to
we
be
don't
greater than
include it?
0, is it?
Sorry?
Is it the case always that we don't include the values exactly, like we use round brackets instead of square brackets?
No, why did we use the round bracket here? Because if you take the value 0, like if you write this is the support, but we know that probability at the point 0 is going to be 0. So we cannot take this as a support.
Ma'am, what if it was 0 less than x less than equal to 1? In that case, can 1 be included?
Okay, so if it was 0, this is what you're saying, right?
Yeah.
So again, at x equal to 1, probability x equal to 1. Since x is a discrete, continuous random variable, again, this is going to be 0.
Okay. So all the time it's round, almost all the times it will be round brackets. Can that be taken as the understanding? Because the exact values at points are zeros for continuous.
Yes. For support.
Okay, so if any problem comes like if you have a density function, find the probability. So you know how to find it, right? We have just discussed before. Like find the probability that x lies between a to b. So finding the probabilities, you have two ways. Either you integrate fx or you find using CDF. So just practice some problems. The method is same. Okay. Okay. Just hold on.
And please explain some questions on exponential distribution.
All right. So in case of continuous random variable, we have studied three distributions. So one is uniform distribution, other is normal distribution, and other is exponential distribution. So one thing is to not get confused between X discrete uniform, okay? Discrete uniform. So if you have a discrete uniform random variable, let's say if I'm saying X is uniform in 0, 1, 2, then just to look at the curly braces, okay? It means X is taking these three values, and each of the values, the probability is going to be same. But if X is a continuous random variable and I'm saying X is uniform, then we are talking about some interval. Like, let's say this is A, this is B, then what is the PDF of X is uniform in this interval? Okay, and it is given by, like, for any X lies between A to B, the PDF is given by 1 upon B minus A. So all this thing, the PDF, the CDF, the formula file that you have will be, it is already there on the portal under supplementary content. The same formula file will also be there. So you don't have to remember any of this PDF, CDF thing. Just remember like how, like if a certain distribution comes and how to like solve the problems on that basis. Okay, so from here, Shrikant will take over. Can you mute?
Shop kelli shampoo testa.
Hello.
Yeah. Yes, you're audible.
Okay. Thanks, Nikita.
Okay, so Shrikant will take over from here. We'll start from week 1, and later on he will discuss one problem from each of the distribution. Okay.
Yeah. One request.
Please share this that PDF.
I will share that PDF. I will put it on Discourse. So can you all please check on Discourse?
We will check it.
Okay.
Thank you.
Thank you, ma'am.
Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Yeah, thank you all. All the best for your exams.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Hello. Shall we start?
Yes, sir.
Yes, sir.
Yes, sir.
Let's start, sir.
Okay. Let me share my screen. Okay.
So your voice is very low.
Oh,
Increase the
I'm
volume.
starting it low. Okay, I will increase my volume. I should shout for 2 hours, right? From here.
No, sir. We will increase our volume. Don't worry.
Volume is already.
Okay. So till now we have seen week 4 half of the contents, right? So what I wanted to do is just take a break at week 4 now. I know many people are having many doubts in week 4. let's just go back to week 1 and we will see some important topics which might help you in your quiz preparations. Okay.
Yes, ma'am. Yes, sir. We want only important topics.
Okay.
Yes.
Okay. So all the important topics, and these are the important topics you are going to use in future also. Okay.
Yes,
So,
sir.
more or less, I covered most of the topics. If not, you just go back and you read every other topics also, if you have time. Okay, so these are the topics I just wanted to more emphasize on and take an example on these topics. So it starts from joint PMF, marginal PMF, and conditional PMF, which are of week 1. And later on, we will move to independent random variables, and we will see sum of two random variables, how the probabilities vary, and what is the max of xy and min of xy in a joint PMF. And later we will see one more important topic, which is sum of two Poisson random variables and some conditional distribution on sum of two random variables. Okay, and in week 3 we see expectation variance, and we are not much worried about this covariance correlation as of now. Okay, I guess it
Why,
is
sir?
Okay. Thank you, sir.
yeah,
Okay, sir. Thank you, sir.
and lastly we will deal with the Markov inequality and Chebyshev inequalities with one example each.
So covariance is not going to be a theme for the exam.
No need to,
Don't ask directly. Just
no need to
understand.
worry as of now. Okay, no need to worry.
Okay, right. Thank you.
Yeah.
Sir, we will get this PDF.
This PDF I will share. Okay.
Okay. Thank you.
Okay.
Sir, your voice is a bit low. Can you please?
So I suggest try using earphones or headphones, whatever you have.
Okay. Okay.
Using that, sir.
I will slowly increase my voice. Do not worry. But
yes.
Okay. Yeah. Let us start with the very first topic.
Sir, what are the things not included? Covariance and
covariance, correlation, and the general see for the n variables, joint PMF and marginals, conditional on n variables. Okay, we are not going to discuss more than 3. We won't be going more than 3. Okay, so let us start with joint.
Yes, sir. Yes, let us start.
I will just give quick recap of what joint PMF and conditional PMFs are, marginals and conditionals. So basically, joint PMF is a joint probability mass function. Yeah.
So will you share this PDF
Yeah,
and
I will
supplementary
share. I will
content?
share. We will share both the PDFs. Okay. Do not worry. And fair warning to all of you: if you distract me, I will get distracted, and it may loss for you and for me. Okay. Follow with me, and it might help you.
About 50 then.
Okay. Yeah. Let us start. So joint PMF is nothing but the joint probability mass function. That means previously we have seen probability mass functions for one random variable. Here we are going to see jointly we are going to see the probability mass function. So if I have two random variables x and y with me, discrete random variables x and y with me, with some probability space, and ranges are like tx and ty. So ranges means what all the values this random variable x can take is tx, and the set of all values y takes is ty. So these are the ranges. Okay. Now joint PMF is denoted like this: f x y t1 comma t2, which is nothing but, so this is same as probability that x take. See, please be on mute, everyone. Lot of noise and it might disturbance. Okay, this is nothing but probability that x taking value t1 and y taking value t2, right? So this is what fxy of t1 comma t2 means, and it is simply written, and we will write it as x taking t1 comma y taking t2 at the same time. What is the probability that x takes t1 and y takes t2 at the same time? And this t1 belongs to tx range. It should be in the range of x, and this t2 should be in the range of y, right? This is joint PMF. And what is marginal PMF? So marginal PMF is if you have two random variables x, y, Okay, xy, and we know the jointly distributed random variables. These xy's are jointly distributed random variables with PMF fxy. If it has joint PMF fxy, then the individual PMF. So if you look at the PMF of x individually, is same as the marginal PMF of x. So individual PMF can be written like this: fx of x or t1 is equals to nothing but the same PMF. How we write the PMF? Fx of t1 is nothing but probability that x taking value t1. So this we can find if you have the table, joint PMF table with you. What you have to do is you just have to pick this column or row where x is taking t1 and you add all the y's. Okay, something like t2 belonging to ty, fxy of t1 comma t2. So if we want the marginal PMF of x, you have to add all the y's. So whatever we are not required, we should add all those. Okay, these all things I guess you people know everything. And conditional is just like when a condition is given, okay. So we have x and y same, x and y jointly distributed with joint PMF fxy. Conditional PMF is something denoted like this: q of t1, which is nothing but probability that, okay, t2, probability that y takes t2 given x takes t1. So given this, what is the probability that y takes this? So the condition, this is the condition. So condition is x is taking value t1. Then what is the probability that y takes t2? Or it is written as f y given x equals to t1 t2. And this we know probability that, so this is just the conditional probability. This is y is equals to t2. Am I audible? Everyone is silent.
Yes, sir.
Yes, sir, you are audible. You told
Yes,
us
sir, we are
that you are
listening.
having
We
problems.
are listening
okay,
attentively
okay.
as your
Okay,
voice is bit low.
Sir, what is this QT2?
It's just the denotion of conditional PMF. It doesn't.
Oh, okay.
So you can directly take this. If y given x is equals to t1 of t2 can be written as probability that y is equals to t2 given x is equals to t1. And this is just the conditional probability. So a given b is a intersection b divided by probability of b. So that is what I am writing. T1 divided by probability that x takes t1. So this is what it will be. So these are on brief of joint, marginal and conditional. Now let's take an example and identify or compute the joint distributions.
Sir, before you start this example, one doubt, sir. Sir, in the exam, means are we allowed? Will there be we can make the table also of joint PMF based on the sum if it is provided.
If it is provided, you can make.
Create one table.
Most
right?
of the times we will give you the table.
Okay. We don't have to create one, right?
No,
I mean, most of the times.
Most of the times.
Okay.
So this is how this is a joint PMF of x and y. Now, first and foremost question is, what is Tx?
What is?
Tx.
0, 1, 2.
Range of x. Range of variable x. Yes.
0, 1, 2.
0, 1, 2.
0, 1, 2.
It's a value that x takes.
X takes, right. What is Ty?
0, 1, 2,
0, 1, 2, 3.
Okay. Now that you have the ranges with us, we have the random variables with us, and we know the joint distribution, right? Now a simple question: what is fxy of 1, 2?
0.24.
0.24.
0.24.
So if the joint PMF is given to you, if you wanted to find the probability that x takes 1 and y takes 2. Just go into the table, go to the row which represents 1, which represents x taking 1, and also the column which represents y taking 2. The intersection point will be the value. So this is simpler one. Now if a question is given on marginals and conditionals, what will you do? What is marginal PMF? What is the value of fx of 1? What should we do?
Sum of all values of
0.6,
sir.
y means 0.12 plus 0.06.
Yeah.
Plus 0.06 plus 0.24
Yeah.
plus 0.18.
0.18.
Correct.
0.6.
So we are asking marginal PMF of x. So you go to the x random variable values and you go to the value, you go to the row in which we are asking. So this is 1, and you just add all the values which are in that row, in that particular
Y
row.
value will change. X will be
Yeah,
fixed.
y value will change. So this is 0.12 plus 0. This is summation. You just change y values which belongs to the range of y, fxy of 1 comma t2. So you just simply change t2. So t2 can take 0, 1, 2, 3. Right? From there we get 0.12 plus 0.06 plus 0.24 plus 0.18. So if you sum this, you will get 0.6.
So what you give as a subscript is the one for which you are setting the constant, is it?
That is what the marginal PMF of x.
Yeah.
Trying to find. Okay. So the marginal, if I ask you to find the marginal PMF of x only, so what you have to do? I need marginal PMF of x. That means I need fx of x for all x belongs to T.
Okay.
Now what should I do?
Sir, in this case,
You can find all the marginals.
Right. You just add all the elements in the first row.
Yes.
Yes.
And second row and third row.
Yeah, second row and third row. What is the first row value? This is 0.6. This is 0.225, I guess. Correct? 0.1.
It will be 1.
0.5, 0.5.
Sir, it will be 1.
Will be 1.
It will be always 1. Right?
Yeah.
Oh, no.
Discrete, sir.
Did we miss any?
No, it's right.
It is 1. Right.
How
Sir,
it's wrong?
So if the marginal is not specified at a particular value, then we need to add all and it will be 1 only, no?
So it is 0.15 only, sir.
No, we are not summing all the marginals.
We are not summing all the margins.
Yeah, you are right, sir.
Am I right? Yeah, I am right.
You are right.
Yes, sir, you are right. You are
Yes,
right.
you
You
are
are
right.
right. You are right.
Okay. I was confused. Okay. So what will be the marginal PMF of x is this. So this is the marginal PMF of x. So x taking x, probability that x takes x. So this is the PMF. Marginal PMF is nothing but the individual PMF of x. Okay, x takes 0, 1, 2 with probabilities 0.25, 0.6,
0.15.
So this is the marginal PMF of x. Okay. Similarly, marginal PMF of y, you should add all the columns and you just make the table, same table.
Sir, there's a question happening for multiple, in case of multiple variables. So, like we have more than 2 variables, so how can determine that variable PMF? Marginal PMF.
Yes.
I will come back to that question. Okay. See, if I see, the problem is we are running very short of time. Okay. Let me discuss what I wanted to discuss, and later on I will take other topic questions.
Okay.
Okay. Okay. So this is marginal PMF of X. Marginal PMF of Y will be, you just have to add this, 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 this. Okay. If you add, you will get 0.2, 0.106,
4.5.
10.5.
4.6.
0.1.
0.1, correct. 0.1.
Yeah. 0.4.
0.4, 0.3. Okay, so this will be the marginal PMF of Y. So in our marginal PMF of Y, you will have one more column, 0, 1, 2, 3, and you will have 0.1, 0.2, 0.1, 0.4, 0.3. So this is marginal PMF. What about the conditional now? So
Sir,
let me give you.
Sir, 1 second. For a marginal, you have to add this all these value 25.25 for X. You should add and give the values. It. Okay, fine. Thank you.
See, for X and for Y, you should add the columns. So, okay, I don't say X, Y. See, sometimes we might confuse you giving Y here and X here.
Yeah.
So, depending upon, which column, which
where
row
it is written.
Represents.
Yes, sir. That thing I don't like.
That is confusing.
But we like. Okay. So, marginal. Okay. Now, let's see conditional. So the conditional PMF, the questions may be like this. F X of Y is equals to 2. So now what you have to do is, it is given that Y is equals to 2. Okay. The condition is that Y is equals to 2. We have to find the probability that X taking value 2. So we know the regular formula. This is nothing but probability that X is equals to 2 given Y is equals to 2. And you can simplify this further. Probability that X is equals to 2 comma Y is equals to 2 divided by probability that Y is equals to 2. Okay. So this is joint PMF, right? Joint PMF Fxy of 2 comma 2. This is Fy of 2. Okay. Now see, Fxy of 2 comma 2, we can find it from the table. What is Fxy of 2 comma 2? Second row, second 0.06.
06.
Yeah, 0.
6. And what is the probability that Y taking 2? From
0.4. 0.4.
So this 0.4 is probability that Y taking 2.
Yes. So it's 0.15.
0.15
by 0.4. This will be 0.15.
15.
Okay. 0.15. So this is how conditional PMF. See, whatever the question is given to you, break it into smaller parts. Go through the basics. So you just convert this to this, this to this, then it is very easy. And one good outcome from this conditional, marginal and joint is joint PMF is equal to conditional plus that we will come to know next. Okay, this is how conditional, marginal and joint PMFs we will find from a given table. Okay, now the same example I take, but let me discuss independence. Okay, what is independence of two random variables, or when can I say X and Y, two random variables are independent?
When joint PMF is equals to product of two marginals.
Correct.
Is equal to.
Correct. So if this particular output, which is when joint PMF is equals to product of is equals to marginal PMF times conditional. Okay, when joint is equal to marginal cross conditional in every case. Okay.
So in every case, this is true,
yeah,
right?
this is true, right?
Yeah. In every case, marginal
Correct,
times condition.
correct. So see, yeah, sometimes.
So for independence, it is not.
I wanted to tell it in the above itself, but
okay.
Yeah, one maybe greatest outcome of this joint, marginal, and conditional is joint will always be equal to marginal times conditional. So even if you know two of it, you can find the third one easily. Okay, that means you see, if I have given you the joint PMF table to you, that means we have given you joint PMF, marginal PMF, along with conditional PMF also. Correct? One small joint PMF table is enough to find any probability based on conditional, marginal, and joint. Okay. Cool. Let's come to independence. Yeah, tell me now, what is X and Y independent means?
Yes, sir. If marginal
Can you
equals
just show
to
the
conditional.
equation? Sorry, just the equation once. Sorry.
Which equation?
Previous one, sir. Joint.
Yeah, joint PMF will be equal to marginal times
Margin.
conditional.
Sir, if marginal equals to conditional, then I think it's independent variable.
Yeah, there are two ways to see this. One easier way to look at it from the table is, if the product of the marginal PMF is equal to joint PMF, what I'm saying is product of marginal PMF is equals to joint PMF for every entry in the table. If it is true for every entry in the table, then X and Y are independent. So product of marginals is equals to joint PMF.
Yes.
This is one, and the second one is conditional PMF will be equal to marginal. Okay, so independent means both are not dependent on each other. So X is independent with Y. So whatever the values X takes is independent of what Y taking. Okay, so if I say Y is taking 2, what is the probability that X is equals to 2 is independent of what is Y taking 3 or 1 or 0, such that probability of X taking 2. So that means even if you impose condition on one random variable, that does not affect on the other random variable. So if condition is not working, so conditional PMF doesn't work. So conditional converts to marginal indirectly. Okay, so whatever X wanted to take, if whatever the probability that X takes 2 is independent of Y. So whatever the probability X takes 2 is nothing but the marginal PMF of X. So that is why conditional will convert to marginal, and product of marginals will be equal to joint PMF. Now tell me, now find the marginals of marginal PMF of this and tell me whether this X and Y are independent or not. Take some 2 minutes time. Okay, how to check is, see, this is marginal PMF of Z X. So this is marginal PMF of X. This is marginal PMF of Y. So compute these values. Compute these 12 values. So this value, this value, this value, this value, and this value, this value, and this value. So what you have to do is, you take this product with this, you should get this. You take this product with this, you should get this. Similarly, take this, you should get this. Like this. If you product the marginals, you should get the joint. For every entry in the...
For one value, it is enough, no, sir?
No. For every.
Oh, okay.
If it does not satisfy for one, then it is not dependent. Sorry, not independent. It will be dependent. Even it fails for one entry, both x and y are not independent. We conclude that both x and y are not independent. Okay, everyone complete.
Independent.
Sir, it is independent.
Independent.
So it means joint
Yes.
equals to product of marginals, na?
Joint equals to product of marginals.
Every single entry in this table is the product of marginal, the joint payment.
Okay, only 4-5 members shouted that it is independent.
And we require to say check second condition also, no? The condition PM.
It will automatically be. So once the above satisfies, it will down one will automatically be.
Then why do we say second as a condition?
Condition is same as joint if it is independent.
No. What I'm telling you,
No, that is one property.
Yeah.
If
So,
the first
you have
property-
written the second line.
So that is one property of independent thing. So conditional PMF will be equal to marginal PMF. So one conclusion you can say.
How do we test that one, sir, in this example?
Okay, let me
Conditional
discuss.
PMF is marginal PMF.
How do we test, is it?
Now the first one is easy. Yeah, we just can multiply marginal PMFs. We can test the cell, intersecting cell.
Okay,
The
second one is also, see, you can see it from, you can actually take one conditional thing like this. So you take fx of
y x is equal to 2 given y is equal to 1, let's take.
And it should be equal to fx of 2. See here, it's a simple proof. Proof also you can do it. fx1 xy of t1 comma t2. If I say x comma y are independent,
Except t1 multiple by t2.
okay, t1 fx of fx given y is equals to t2, you can write it as fxy of t1 comma t2 divided by fy of t2, correct?
Right.
Now if x and y are independent, then this above joint can be written as product of marginals, fx t1 times fy t2 divided by fy t2. Okay, this will cancel out and you will be remained with fx of t1. Now this is nothing but marginal PMF of x. This is conditional. We started with conditional PMF and we got marginal PMF. Okay, tell me whether these are independent or not, other than the...
They're independent.
Yeah,
independent.
Yeah. So you just compute this value.
Independent.
Yeah, we will get 0.25, 0.6, 0.15, 0.2, 0.1, 0.4, 0.3. So whatever the marginal you take 0.4, 0.6, you just product it, you will get 0.24. Similarly, 0.3, 0.6, 0.18, 0.3, 0.25, 0.075, like this. So 0.2, 0.15, you will get 0.03. Okay, whatever combination you take, we will get the product will be equal to product of marginals will be equal to joint PMF. So this x and y are independent. This is how you check whether two random variables are independent or not if a joint PMF is given to you.
So I didn't get this 0.05 and 0.03. I didn't get that, so 0.05 and 0.03 is something, no?
0.05 and 0.03.
Yes.
There is, see, here you will get 0.2 if you add this. You just add these three values.
That I got, sir.
You got 0.2. Here you got 0.25.
That is for 0, right? Like,
Yeah.
x equals 0.
So we need to check fxy of 0 comma 0 whether this is equal to fx of 0 times fy of 0 or not. So for this first entry, okay, fxy of 0 comma 0 is 0.05. Now right hand side is fx of 0 is 0.25 times fy of 0 is 0.2. So what is 0.25 times 0.2? 0.05. So the product of marginals is equal to the joint in this particular entry. Correct? So 0.2 times 0.25 is equal to 0.05. Similarly, you have to check for every other entries. So there are 12 entries here. So you have to check for all combinations of T1 comma T2, where T1 belongs to the range of x and T2 belongs to the range of y. Okay.
Yes,
This is independent. Now what about sum of random variables? So the same table I have, but I wanted to know the sum. So x plus y distribution, x plus y PMF. So the PMF of x plus y. So first and foremost thing you have to do is you have to find the range of any given random variable. Okay, even it is sum of two random variables or division of two random variables, whatever, you just try to find the range of. So let me say this as z. Now tz will be
0 to 5.
0 to
5.
Correct. So we can have 0, 0 plus 0, 0. From 0 to, you can have till 2 to 2 and 3, 5. So tz can take from 0, 1, 2, 3, 4, 5. Now, as I said, PMF of x plus y, I need to find fz of 0, fz of 1, fz of 2, fz of 3, fz of 4, and fz of 5. Correct? This is the PM. Once you got this, you just put it in the table like this. How we put? Like this. X is equals to taking x and probable, x plus y. Okay. Z taking small z. Probability that z is equals to z. 0, 1, 2, 3, 4 and 5. Okay. Now I have given you the table here. So this is the table I have given to you. I need, okay, first compute this thing. Fz of 0. I need fz of 0. So that means sum is equals to 0.
0.
What is the
0.05.
0.05. Okay. Okay. This is 0.05. So the only case possible is probability that x is equals to 0 and y is equals to 0. Correct? Okay. Now I want, what is the probability that sum becoming 1?
0.145.
0.145. Yeah, 145. What all entries did we add?
0, 1, 1, 0.
0.12 plus 0.025.
0, 1, 1, 0.
0, 1,
1, 0.
And 1, 0.
So see here. So from here, just observe. For sum, what we are doing is, you just take the diagonal lines like this. Now see, on the diagonal lines, you see the sum will be same. So this particular line, sum will be 0 only. And this particular line goes in these two entries. So if you see the sum 1 plus 0, 0 plus 1, both sum to 1. So this corresponds to z is equals to 0. This is z is equals to 1. Z is equals to 2. See, for 2 you see, 0 to 1 1 2 0. There are three possibilities, correct? So even this line goes like that. 0.1 plus 0.06 plus 0.03 is z is equals to 2. So this we got 0.145.
I didn't get the FC of 0 is 0. Instead of 0 equals 0.05.
Your voice is too low for me. No.
I didn't get it, sir. Fz of 0 is 0.05.
See, fz of 0 means what is the sum of the random variable, sum becoming
can you
0.
zoom it, sir? Can you zoom it, sir?
Yeah. When can the sum be 0? So given these random variables, x takes 0, 1, 2 and y takes 0, 1, 2, 3, what is the probability that sum x plus y takes value 0?
Both should be 0.
Both should be 0, right? The only case possible is both should be 0, or else the sum will be more than 0. So asking that sum, probability that sum is 0 is same as asking the probability that x is equals to 0 and y is equals to 0, right?
Yes.
So that is what we have taken. So what is the probability that x is equals to 0 and y is equals to 0? From this joint PMF you can see, right? This is the value. This is the joint PMF of x is equals to 0 and y is equals to 0, which is 0.05. So therefore fz of 0 will be 0.05. Similarly, when can the sum be 1? Either when x takes 0, y takes 1, then the sum will be 1, or x takes 1 and y takes 0, the sum will be 1. Correct? So what is the probability that x takes 0 at the same time y takes 1 is 0.025 plus there is another chance. There is another chance that y can also be 0 and x can be 1. That is 0.12. So 0.12 plus 0.025 will be the probability that sum, which is x plus y, takes value 1. Similarly, for 2, we have three possible cases. For 2, you just see for 2, x can take 0 and y can take 2. And x can take 1, y can take 1. And x can take 2, y can take 0. There are three possible cases. So you should add all the three cases probabilities. So each case has probabilities 0.1, 0.06 and 0.03. So this will sum up to 0.19. 0.19. And this is fz of 3. Now for 3, you just have to check what all the possible cases are there. For 3, when x can be 2 and y can be 1, x can be 1, y can be 2, x can be 0, y can be 3. Correct? These are the three possible cases for which z, the sum can be 3.
Either way, you can flip it also, right?
Still zoom. Okay.
No, what I'm saying is, x and y you can interchange the values, right? Like 0, 3, 3, 0.
See, if 0 and 3, 3, 0, x cannot take 3, right? There is no.
Oh, sorry, you have 0.
X takes
Okay,
till
correct,
2
yeah.
only.
Yes.
Correct? Yeah. So that is why we have only three possible cases. You just sum all these possible cases,
Yes.
we get 0. What is this value?
0.33.
33.
So 0.33.
9. Okay. Going with you. Okay. This is 0.33.
0.33.
Now similarly calculate when can sum be 4. Either when x takes 1, y takes 3. When x takes 2, y takes 2. So these are the only two possible cases we have when that such that sum will be 2. Sum will be
0.24.
So you just have to add these two, that will be equal to 0.24. So make this 0.24. And finally, when will be the sum be 5? So only case possible is x taking 2 and y taking 3. That is 0.045. So once you are done with this, just for cross checking, make sure not to go wrong. You just add all these
entries,
all these values, you should get 1.
1.
Okay, just to make sure that we did correct, or we are not leaving, or we are not writing 5 in place of 4 or something like that. Okay, just to make sure, you just add all these values, you should get 1. So this is now the PMF of the sum will be like this: 0.05, 0.145, 0.19, 0.33, 0.24, 0.045. Okay, this is the PMF of sum of two random variables. So also visually, if you wanted to see, you draw the diagonal lines. I don't know, right tilted diagonal lines, maybe you can say these diagonal lines. So just remember the diagonal lines for sum. Okay. Now let us discuss for max and min. Okay.
Excuse me, sir.
Hmm.
Can you also please solve that conditional probability one that you wrote? Just one example.
Conditional probability I just solved, right?
No, the conditional probability is equal to marginal probability.
Okay, conditional is equal to marginal.
Yeah, the one that you wrote, and
okay,
you already took an example. Can you please solve that?
Okay, this one, huh? This one.
Yes, sir.
So you see, this will be f of xy 2 comma 2y, f of y is equals to 2, correct?
Yes, sir.
Sorry, f of
X
y 2 y. So x given y is equals to 2.
Yeah.
Okay. So what is f of xy 2 comma 2?
0.026.
Okay. This is 0.06. What is fy of
0.04.
0.4.
Yeah.
0.4. If you divide this, you will get 0.15.
Okay.
Okay. And this 0.15 is nothing but equal to fx of 2.
Yes.
Okay.
Yeah.
You can check for any other. It will be.
Okay. Yeah. Thank you, sir.
Okay. Now let's see for.
So this one small thing. Do both the conditions of that product and the condition equals to marginal have to be true for independence?
Which one? Product?
Like both the conditions, like these two, have to be true for
These
independence.
two will be true for independent random variables.
Okay. So like we have to check both for like checking
No.
independence.
First condition is enough to check.
Okay.
Second condition automatically follows. Okay.
Okay.
Even if you are having time, you check with second condition. Okay.
Okay.
Got it. And everything. Okay. Now let's come to a new random variable z, which is max of x comma y. What is max of x comma y?
The very like in 0 and 1 is max.
Yeah. So when these are random variables, right? X and y are random variables. This takes some random number and this takes some random number. So among those two random numbers, which is maximum, that we will take. Okay. Now here you see. Okay. Now what is the range of
0, 1, 2, 3.
0, 1,
2, 3.
Correct. Only this particular random variable z can take 0, 1 or 2 or 3. Now we have to find fz of 0, fz of 1, fz of 2 and fz of 3. So this is the joint PMF, sorry, this is the PMF of a new random variable z, which is max of x comma y. Now when can z takes value 0?
Sir, is it a continuation of the previous table or it is the new table which you wrote?
Same table I took, but the new random variable, now the random variable is okay, just star maybe. Okay. This
Why
is
is star?
New random variable, not the previous one.
Okay.
Okay, z1. Okay, so that particular z is sum of two random variables. This z1 is max of these two random variables. Okay.
Yes, sir.
Okay. Okay, now when can this max is equal to 0? What is the probability that max
when x and y both is 0?
X and y both are 0. So if x takes 0 and y takes 0, maximum of 0 comma 0 is 0. So that means this is also the same thing. Probability that x is equal to 0 and y is equal to 0 is the only case, and this is equal to 0.
0.05.
Now when can this z1 max of x comma y takes value 1?
0.12 plus 0.025.
1 also.
Yes, 1 also.
Yeah, 1 1.
0.011.
Plus 0.06.
Yeah,
That sums up to 0.205.
correct. See, there are three cases: max of 0 comma 1, max of 1 comma 0, max of 1 comma 1. So these all will give me the value 1. Right? There are three possible cases, so we need to add all the three.
So here we cannot use the diagonal line.
Here it is not diagonal. I will show you by pictorial representation also. So what we are doing is boxes. What happened, Aditya? Like this. It will be like this open boxes. So you see this box, above this box, it will be only 0. So this box represents z is equals to 0. And this box will be z is equals to 1. This will be z is equals to 2. And this box will be, this box means this box is z is equals to 3. Okay, you can see. So in this box, there is only one possible case, which is x is equals to 0 and y is equals to 0. In this box, there are three possible cases: 0, 1, 1, 1, 1, 0. So you just have to add all the three possible cases for z is equals to 1. Z taking value 1. So if you add all those three, we get 0.031, 0.151, correct? 0.151. Am I correct? Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
What happened? Am I correct, or are you guys lazy, or
No, we are just calculating.
We just got distracted there. Okay.
The max of
Sir, it will be
0.205.
It will be
0.205. 0.205.
0.205, correct. Or do you guys need break?
For 2, it is 0.445.
No.
No break, sir.
No.
It's okay.
Fine, right?
Yeah, we are fine, sir.
Okay. If you want, I can give you some 2-3 minutes break. Just
Please
relax
check
from
with
the-
Aditya. He's okay. Check with Aditya. He's okay.
Yeah, I am okay. I am okay.
That is what I asked you.
That was a mistake.
Okay. And everyone are silent. I just asked to sum three values and everyone are silent. So that is why. Okay, 0.205 will be the value, that the probability that Z1 taking value 1. And what about Z taking value 2? So how many entries are there? So 0 comma 2. Possible cases are 0 comma 2, max of 0 comma 2, max of 1 comma 2, max of 2 comma 0, max of 2 comma 1, max of 2 comma 2. So there are 5 possible cases for which Z1 takes value 2. So we have to add 0.03 plus 0.015 plus 0.06 plus 0.1 plus 0.24. So this will sum up to
0.58.
0.58. Okay. Similarly, the last one, Z max taking value 3 is when Y takes 3 and X taking any other value. So 0, 3, 1, 3, 2, 3. So 3 possible cases. You just have to add 0.075 plus 0.18 plus 0.045, which will be 0.3.
So here also summation will be 1, right?
Yeah, here also, even after computing this, make sure to add all the 3. Yeah, make sure add all the 3. Why it is not coming 0.1? Will it come 0.1? It is not coming 0.1. Oh, I think I need break.
Sir, it is 0.445 for 2. Z taking value 2.
Yes, for 2 it is 0.45.
Is this 0.3 correct?
Yes.
Okay, then Shaival, you should take break. Okay, so yeah, once you get all the values, that is why I tell you, just make sure add all the values. If you get 1, then you are correct. If you are not getting 1, then you have to redo some of the calculations. Okay, here we will get 1. Okay, now the same thing, another random variable Z2. This is min of xy. Now what is range of this random variable Z2? This is the table.
0, 1, 2.
0, 1,
0, 1, 2.
correct. 0, 1, 2. Okay. So we have to compute only 3 values for PMF. Fz2 of 0, Fz2 of 1, Fz2 2. Okay. So when will be the minimum of xy be 0? So what are the possible cases? Minimum
1.
0.
Only 1. 0.05.
No, 0, 1, 0, 2, 0, 3.
Wherever 0 is there, right?
Yeah.
Wherever 0 is there, yes.
Yeah.
Even if one of x and y takes 0, minimum will be 0.
5 cases.
So
Okay.
this. So this.
6 cases.
Right, these 6 cases. 1, 2, 3, 4, 5, 6. So in all these 6 cases, minimum of x comma y will be 0. And the second one is 1. And there are 4 cases such that minimum of x comma y takes value 1. And there are finally 2 cases, minimum of x comma y takes value 2. Okay, you see the difference. For max of xy, we draw these lines, upward opened boxes. And for min, we draw downward opened boxes. Downward open boxes or half boxes. Okay. Got it?
Yes.
Everyone?
Yes.
Everyone?
Yes, sir.
Yes, sir.
Okay. So this is about some min max when a joint PMF is given to you. Okay, let's move a little forward in this week 2 only. So yeah. So you compute those values once I share the PDF. And one important thing is sum of to Poisson random variables. So we have two random variables. One is x follows Poisson lambda 1 and y follows Poisson lambda 2. So what is the distribution of x plus y?
Lambda 1 plus lambda 2.
Poisson only lambda by 2, I think.
Poisson lambda 1 plus Poisson of
and,
lambda 1 plus lambda 2.
and one more condition I need to give.
Lambda.
X, y are independent.
Yeah.
Bina independent, I didn't said anything independent, you are assuming it. Huh? X and y need to be independent, okay? So there are two independent random variables, x, y, which follows Poisson lambda 1 and Poisson lambda 2. So what I want is a new random variable x plus y, sum of two Poisson random variables. So what is the distribution of this sum? So sum said lambda 1 by lambda 2. Okay, I will give you options. Poisson lambda 1 by lambda 2, Poisson lambda 2 by lambda 1, Poisson lambda 1 plus lambda 2, Poisson lambda 1 lambda 2.
C. Option C.
Option
C.
C.
Lambda 1 plus lambda 2.
Okay. Any other options other than C? Okay. It will be option C. It will follow Poisson lambda 1 plus lambda 2. Okay, some will also follow. You just have to add the parameter values of those two Poissons and make a new Poisson.
So will it change if they are not independent?
Yeah, if they are not independent, then this is not true. This will not follow. See, if you want the proof, you just go back to the lecture, I guess.
No proof needed, just asking.
Yeah, in proof we actually use the independent condition. So that is why I'm saying. So in order to get this particular sum follows Poisson lambda 1 plus lambda 2, we actually use independent condition.
I'm thinking only from which point of view, that if they are not independent, then what will happen?
If they are not independent, then sum is something other. It follows some other.
Okay, got it.
Random distribution.
Got it.
Okay. Okay. And now in this sum only, there is one more thing. This x given conditional distribution. X given x plus y follows something. Y given x plus y follows something. Can anyone?
I think then it becomes, I think,
binomial
and then some
lambda 1
is there. Yes,
by lambda 1 plus
lambda 1 by lambda 1 plus 2 and then lambda 2 by lambda.
Binomial n comma lambda 1 by lambda 1 plus lambda 2.
Okay. So let me take this and correct. This is binomial n comma, for x it will be lambda 1 by lambda 1 plus lambda 2. For y it will be binomial n comma lambda 2 by lambda 1 plus lambda 2. Okay. So these are one good.
Again independent, both are independent.
Yeah, independent. The same thing, same follow, same things. Now let us take one small example on this particular whatever we discussed. So there are some two random variables x and y independent. It represents number of calls received by A and B call centers in a 1 hour interval. Suppose x follows Poisson 1 and y follows Poisson 2. Let z is the total. Let z be the total number of calls received by both, means the sum, both A and B. Now what is x given z follows, y given z follows.
Set is 6 comma 1 by 6, no sir?
This follows. Let me give you 4. Okay. Now tell me.
4 comma 1 by 6.
binomial
4, 1 by 6.
1 by 6. Correct. This
4, 5 by 6.
4, 5 by 6. Everyone agree? It's just lambda 1, lambda 2. Just now we talked about lambda 1, lambda 2. I just replaced lambda 1, lambda 2 with some discrete values.
1 and 4, 1 and 5, right?
Yeah, 1 and 5.
So from here we have n is coming. Okay, z equal to 4 is given us.
Yeah.
Sir, n the so how did it come? Like
10?
N 4. Z is equal to 4. How did we get?
I
Is it
gave.
Much.
Okay. Okay. Now find the value of fz of 2. That means the total number of calls received by both A and B is 2. What is the probability that we get only 2 calls? Okay. In small, what is Z? What is the distribution of Z?
X plus y.
Poisson?
Lambda 1 plus lambda 2. 0 to 6.
Distribution of Z will be Poisson 1 plus 5, right? Lambda 1 plus lambda 2. Okay. Now we know Z follows Poisson 6. What is the probability that Z taking value 2?
So e to the power minus lambda and then lambda to the power 2 by factorial, so something like that, sir?
Correct. E to the power minus 6
lambda
into
lambda
6
to the
power
power 2
divided by 2 factorial.
by 2 factorial.
Correct? So this, if you simplify this will be the answer. Now, what is the value of f y given z is equals to 2 of 1? So that means conditional distribution. We are asking the conditional distribution. Given condition that z is equals to 2, what is the probability that y takes value 1?
So fy1 into fz2 divided by fz2.
You can go like that, but see there is some sort of shortcut. So what is this distribution? You just see what distribution this follows.
That's a binomial.
Yeah.
Binomial.
This is binomial, right? So this is where you shouldn't confuse. Even though it might look conditional, but it is simple binomial. So
if I go by that method also, I will get the answer, right?
You will get the answer, but that is complicated, right? That
yes,
you have to deal with Poissons.
Got it. I was just checking. Yes.
Yeah. So this will be this particular y given z is equals to 2 follows binomial 2 comma 5 by 6.
5 by 6.
So if this follows 2 comma 5 by 6, what is the probability that it is taking value 1?
Sir, 5 is lambda for y, right? Hello?
5 is?
Lambda, value of lambda for y, right?
Y, yeah.
Yeah, then what about 1, sir? This 1, where 1 is coming into picture?
See that 1 is this particular random variable taking value 1.
मुझे भूख लग रही है.
You can go eat. Okay. For not to confuse, I will just simply remove.
Question here. It will be e power minus 2 and 2 power. Is that the way you are going to go about with this?
No. I'm not going to that way. So let me take this as some new random variable, maybe some w. So I just take this as w. Okay.
We want to say 2c1 is equal to
Okay. Now I just took this conditional random variable as w. Y given z is equals to 2. I just replace that whole with w. this whole with W, and this W follows binomial 2 comma 5, 2 comma 5 by 6, I know. Now I need simply FW of 1, where W follows binomial 2 comma 5 by 6.
So we can use like e to the power.
फिर से e to the power.
Then it will be 2 choose ones or what? 2 choose
I am
one?
asking very simple one. What is the probability that W taking value 1, where W follows binomial 2 comma 5 by 6?
Isn't it 2C1?
2C1.
5 by
5
6.
to power 5 by 6 to the power 1.
Yes.
5 by 6
into 1 by 6.
At least few people.
To the power
2 minus 1.
2 minus 1.
Into?
Power 2, 1 by 6 power 2 minus 1, which is actually 1.
Which is actually 1. Yeah, 2 minus.
One doubt is there.
That's it.
So, sir, how we are arriving that in this case you told that it is a binomial. Okay, why condition given z equal to 2? Okay. So means how we can check that okay this thing we can go with the binomial formula.
Correct. Okay. So that has a proof. If I wanted to prove, I can prove, but it takes some 2 to 3 minutes. Okay. So this is actually a class proof. You can actually do this simple proof only. So if I say x given z is equals to some n. Okay. This is following binomial n comma lambda 1 by lambda 1 plus lambda 2 is what we say. Okay, let me try to give you that thing.
Okay.
So I try to find the PMF of this when x takes value k given z is equals to n. So I can write this probability that x is equals to k, z is equals to n divided by probability that z is equals to n. Right? I just
Right.
written it as joined by marginal. Now see, x is taking k and sum, this z is nothing but sum, right? X plus y taking n.
Yes.
Okay. X takes k and x plus y takes n. Okay. This is nothing but this is k. So y equals to n minus k. And we know that x and y are independent. This will be probability that x is equals to k times probability that y is equals to n minus k divided by probability that z is equals to n.
Okay.
Okay, x is Poisson, y is Poisson, z is Poisson. This will be probability that x is equals to k will be e power minus lambda 1 times lambda 1 whole to the power k divided by k factorial into e to the power minus lambda 2, this probability. Lambda 2 into lambda 2 power n minus k.
Sir, if it is independent, then why we are dividing it by probability of z equals to n?
See, that is different, right? Probability that z is equals to n is different.
Really,
from
x and y
probability-
are independent, but z is, I mean, x is not independent of z, right?
Yeah, x is not
Exactly.
independent of z, and x is not y is not independent of z.
Of z, yeah. It's the sum of both, so it cannot be independent.
Okay. Now z follows. So we know that Poisson lambda 1 plus lambda 2. It's just lambda 1 plus lambda 2 times lambda 1 plus lambda 2 whole to the power n divided by n factorial. So this will get cancelled. Ultimately, we will remain with something like this: n factorial by k factorial into n minus k factorial. One is lambda 1 by lambda 1 plus lambda 2 whole to the power k. Another thing, you can write it as lambda 2 by lambda 1 plus lambda 2 whole to the power n minus k. So you just divide this lambda 1 plus lambda 2 whole to the power n as lambda 1 plus lambda 2 to the power k times lambda 1 plus lambda 2 to the power n minus k. Now this will convert like this. Okay. From here it is easy to see this power. This is something like binomial.
Understood. Thank you.
Okay. If you want detailed proof, you just go back to the video lecture. Okay. Okay. So yeah, this is So no need to go with Poisson tables and everything. Even if you do like that, you will ultimately every e to the power will get cancelled and ultimately you will remain with this. Okay.
May I ask one question here?
Yeah.
Now, when you actually showed this Poisson plus Poisson is binomial, that's one combination. But are there other combinations also?
No. Poisson plus Poisson is Poisson.
Okay, Poisson plus Poisson is Poisson. Okay.
Poisson given
Conditional.
Poisson is binomial.
Okay.
Where that other Poisson is sum of two random.
Yeah. Okay. Okay.
Can you repeat?
Can you please repeat?
Which one?
Like Poisson plus
Your
Poisson.
voice is very low now, sir.
No, what you just said last.
What I just said last is Poisson plus Poisson is Poisson. Okay. Where x and y are two Poisson random variables, where x and y are independent, then the sum of two independent Poisson random variables is a Poisson. It will follow Poisson with parameter lambda 1 plus lambda 2. But if the sum is some other random variable z, and x given z and y given z are binomial n comma lambda 1 by lambda 1 plus lambda 2, and y given z will be binomial n comma lambda 2 by.
So, sir, Poisson plus binomial is binomial.
No. Poisson plus binomial. Abhi, we have to create one. See, this PDF I will give you. Okay. This is what I have written.
Sir?
Huh?
I think someone asked a question and that got missed out somewhere. I think Ravi was asking a question that what about other combination? Is there any other combination?
Other combinations as of now, we in the lectures also, sir didn't discuss, professor didn't discuss.
Yeah, sir has not discussed.
Yeah, we also.
So we cannot expect any question from that.
That see, most probably no. Whatever we discuss, that is what we give you.
Yes.
Okay. So this is how you find. See, even if you follow from basics, you can go it from the basics. You can just convert this conditional to joined by marginal, and you can use the different Poisson formulas for each of the random variables, and you compute. Even then, you will get this value.
I'm facing problem where to use Poisson and where to use binomial.
Where to use Poisson? See, sum of two Poissons is Poisson. Okay. But conditional, in condition, it might change. See, the conditions like x given sum will follow binomial this.
Okay.
Y given sum conditional will convert to binomial. If it is only sum, it is Poisson only. Okay. So those are some important topics which I wanted to discuss in week 2. Let's come to week 3.
Ask a small question here, sir, related to conditional probability. So like we discussed about, x1 conditioning on x2 or x conditioning on y or y conditioning on x. Say for example, if it is there in lecture also, that's why I'm asking. If my x1 is conditioned on, you can write it also, sir. F x1 is conditioned on f x1 is conditioned on x2 equal to t2, x2 equal to t2, comma x2 equal to t3, and then in bracket t1. So the formula comes out that fx1, x2, x3 bracket t1, t2, t3 divided by f x2, x3, t2, t3, right? Right, sir. So my doubt comes here now, how I will find this x2, x3? How will I find this one? Again, I will have to use conditional, or how will I find out this one? F2, x3.
It might have given you that x1, x2, x3 are independent. Is it given?
That I will have to check it out, sir.
It should be given.
That part I don't remember.
So what happens is, here you can see this particular thing, you can write it as f x1 is equals to t1. Sorry, probability that x1 is equals to t1, x2 is equals to t2, x3 is equals to t3 divided by probability that x2 is equals to t2, x3 is equals to t2. Correct? This, can I write it like this?
Yes, sir. Yes,
Okay.
sir.
And the numerator is nothing but this.
Yes.
And the denominator, you see,
like this, yes.
This.
So if they are independent, I will simply multiply.
Okay, no need of independent
It is
also.
just like
It
it
is
is just
direct.
like joint.
Yeah, it is just the conditional is equals to joined by.
No, if no, what I am asking, if x2 x3 is not given, then how will I find it out?
Which x2 x3 is not given?
The denominator part, sir. The denominator part.
Denominator part.
Yes. So for example, there is no table, right? So then how to figure it out? If it is independent, then simply I will multiply by their marginal probability, right? If it is not independent, then how will I figure it out?
Then you I don't think, is this a complete question? Can you just
yes, this part is there, sir.
This part is there, but I need the complete question to in order to address.
Okay, then let us continue. I will find out that.
Yeah, you will find out meanwhile. Okay, now let's come to the expected value of a random variable. So x is a random variable. Let us say x is a random variable, and also the same thing, tx is range of this random variable, and this particular random variable has PMF some fx. It has PMF fx. Now the expected value is given like this. Expected value of this x is given like this. It is summation of t belonging to tx t times fx of t. Okay, so this is simply, you can write it as t given t belongs to tx t times probability that x taking value t for all t. Okay, so for all t. Okay, so this is what expected value of a random variable is, in short, in brief. So this expected value is nothing but mean of a random variable. Okay, and also one important property of this expected value is, many people might not convince, or many people will think that we are going wrong. Sometimes this particular expected value may not belong to the range of x. Sometimes the expected value which we compute may not belong to the range of the values which x takes. So it may come outside the range of x. Even then it can be the expected value.
Will within the range, but x might not take that value. Like in case of throwing a die, it is coming 3.5, but x
correct.
is not taking 3.5. X is taking 1, 2, 3. So it will be within the range, but the value may not belong to the range.
Yeah, it will be, expected value will be inside the smallest and the largest.
Correct. But my random variable may not take that value.
Yeah, may not.
It will be in the range, sir, but it will be in the range only.
The range.
It will be inside,
Yeah.
within the range. Yeah, correct.
Yeah, it may not be discrete, but it will be in the range.
Right. So this is one important property of expected value. And yeah, some important expected values of some common distributions are like this.
So these things will be given.
Given. It will be given. Okay. But
Sir, I have one doubt in conditional probabilities.
Let's skip this.
I will skip this.
Wait a minute, hold on. Just let's note it down.
Just I will share this PDF anyway. You don't need to worry. Okay. For Bernoulli, the expected value will be p. For uniform 0 to n, it will be n by 2. For uniform something in between a to b, discrete, it will be a plus b by 2. For geometric, it will be 1 by p. Poisson, it will be the same parameter. And binomial np will be np. Okay. Very easy formula to remember, but even if you didn't remember, we will give you this.
So can you give a small example for the expected, what kind of question you can expect? A small example.
I will give.
Okay.
I will discuss with examples only. Okay. So this is one simple, easy enough example. I guess everyone can solve if you know the formula. So here a random variable x is given, which takes values 1, 4, 9, 16. What are these 1, 4, 9, 16?
The square of 1, 2, 3, 4.
Value
Cube.
my random variable can
Square.
take. Value is my random variable can take, and the other one is probability.
That's its square.
That is correct, but I am asking what are these 1, 4 in numbers? What are these 1, 4, 9?
Is it the range, sir? Range of X?
Range of X. Random variable.
Okay. I was just expecting
It's a
simple
square
answers.
of natural numbers.
Square of first four
natural.
natural number. Square of first four natural number.
Correct, correct. Okay, so the above one is the values which X takes, and below one are the probability that X takes that particular value. So probability that X takes 1 is 1 by 3, like this. I need to find the expected value of X.
8.833.
0.833 in fractions.
In fraction, it's 53 by
50 by 6.
53 by 6.
53 by 6, 1. 50 by 6, another one.
Sir, I have one doubt in conditional probability, sir. Can I ask you, please?
Conditional probability, please.
So the question is x1, x2, and x10, so on are 10 IID Bernoulli 1 by 3 samples. Let y be a random variable defined as y is equal to x1 plus x2 plus so on up to x10. So I have a doubt in how to find this conditional, sir. X1 is equal to 8, condition y is equal to, x1 is equal to 1, condition y is equal to 8.
Okay, I will discuss that particular questions. Okay, meanwhile, you identify what is the distribution of y in that. So if x1 to x10 are Bernoulli.
Sir, why I found the distribution binomial 10, 1 by 3.
10, 1 by 3, correct. Now, what I want is probability that x takes value 1 means first Bernoulli value taking 1 and the sum taking 8. So what all the possible cases are there? So first value, so you take it as like a coin toss, okay? Head means value 1, tail means value 0. So what is the probability that my first toss is head, given that there are total of 8 heads? Okay, that is what the question is. Okay, you just convert that conditional to joint divided by marginal.
That's what I did, sir, but I'm not
able to find
able to understand.
Okay, I will come back to that question. So what is the answer for this expected value?
Okay.
No one trying.
53 by 6.
3 by 6. 3 by 6. Okay, it's just the expected value of x. You just have to write it like summation t belongs to tx, t times probability that x takes t. So as this is summation 1 times 1 by 3 plus 4 times 1 by 12 plus 9 times 1 by 6 plus 16 times 5 by 12. Correct? So this is 1 by 3 plus 1 by 3 plus 3 by 2 plus 3 by 2 plus 20 by 3. So 22 by 3 plus 3 by 2. 44 plus 9. 53 by 6. Correct. So this is how you compute expected values when this PMF is given to you. But what if it is given in words like this? So in a particular game, a player gains 100 rupees with probability 0.25 and loses 50 rupees with probability 0.1 and no loss low gain with probability 0.65. Now find the expected gain.
Uh, 20. 20.
Or is it 20?
20. Okay. So let x be simply let x be the random variable where it takes the player gain or loss or no gain no loss. So that means x takes 0, which means no gain no loss, or x takes 100 or x takes minus 50. So if he loses, he have to pay. So X denotes the gain of that particular pair. So X takes value 0, 100, minus 50. So this probability is 0.65. This has probability 0.25. This has probability 0.1. So the same formula you use. So the expected value of X will be 0 times 0.65 plus 100 times 0.25 plus minus 50 times 0.1. So this is 0 and this is 50 minus 5. What is happening? This is 25, sorry. 25 minus 5, which is 20. So the expected gain will be 20. So now tell me whether he can play the game or he just have to quit.
Play.
Yes, play the game.
It's safe to play the game, right?
It's safe
So
to
he will gain.
Yeah.
What is the value of ticket also? That what will be the value of ticket that?
Value of the ticket, yeah. Maybe.
If it is 50 rupees, then I will not play.
Correct. Okay. And there are few more properties of expectations. So it's called as linearity of expected value. So linearity holds here.
No, sir. In this question, the value of ticket doesn't matter.
Oh, it does. You spend 100 to pay 20.
No, here it is clearly written you are gaining something.
There will be some charge which you will have to play to enter.
Yeah, it means that is profit.
Okay, then play. Leave it. Let us discuss this.
We will play after the exam.
Okay.
Yes, we'll play after the exam.
Okay. Now let's come to this linearity of expected values. So whenever a random variable is multiplied by C, if I have a random variable X, and each and every outcome of that random, each and every value or the range of values of X is multiplied with C, that means which is Cx, which is small c multiplied by X, the expected value of this Cx will be C times expected value of X. So this is called linearity of expected value. And one more thing is expected value of X plus Y. So if you have two random variables, you can actually split it into expected value of X plus expected value of Y. Okay. And if I add linearity into this, A times X plus B times Y, simply this will convert to A times expected value of X, B times expected value of Y. Okay, this is linearity of expected value. Okay.
So will there be a scenario for some kind of X plus C? C is a constant kind of thing.
Yeah, X plus C. What happens X plus C? Expected value X plus C. This will be expected value of X plus expected value of constant. So expected value of C. What is expected value of C? It will be C. 0. Expected value of a constant.
Anything to do with products also?
It will be C only.
So it will be C only.
It will be C only. Sorry, it will be C only.
It will be C only. Expected value of a constant is that constant only.
Yes. Variance is 0. Sorry.
Variance will be 0.
Yes, my mistake. My bad.
Okay.
Expected value of product of two random variables is that E of xy. Is there something?
That is comes under independent case.
Okay. Somebody is really chomping down, huh?
At least mute and eat, na. Everyone will become hungry after hearing it.
She's still continuing. She's still continuing. Whoever that is.
Sham. He has put his mobile aside and he is concentrating on it.
Sir, and E X minus Y, we can say EX and minus EY, right?
See,
That's
plus
all.
minus plus hoga minus. Okay.
But in case of variance, actually it becomes positive.
Yeah, variance we will discuss.
Yeah.
So if independent, we can make the product as well, correct?
If independent, yeah. If independent, expectation of xy will be expectation of x times expectation of y.
Sir, just a follow-up question to this one only. Product and divisions are both, sir.
I will come to it. I will come to
Okay.
it. Let me take one by one. Okay.
Okay.
So variance is actually how much the random variable the values of x is distributed around the mean. So that means the mean of whole square. Why we make whole square is we are seeing only the difference, like positive difference, error. Even if it is on the left side or the right side, it doesn't matter. We need how much far the random variables are placed, the values are placed around the mean. So that is why we take square. So now this, if you simplify this, if you open the square, simplify and everything, if you do it, simply you can take it as expectation of x square minus expected value of x whole square. You just do the math here. A minus b whole square. You just open it, you just do every other stuff. Okay, variance of x will be expectation of x square minus expectation of x whole square.
Sir, if that square is only for that converting negative to positive, that we don't care about the expectation is up or down, then we could put mod there.
Mod is quite different from squaring. So you see, you will get to know why we use square instead of mod. If you know, if you done max 1, max 2, x square is much more easier to handle than mod x.
Yeah, differentiation is possible in x square.
Square is differentiable, whereas mod x is not differentiable. When you do machine learning courses, you will use linear regression there. Okay. You have to minimize some cost or anything. Then you try using, you will minimize using square formulas because you have to differentiate there. You have to get the peak points. So in order to get the peak points, you have to differentiate your function. Whereas mod x doesn't give you that liberty to do. Okay. Okay, we can have this good discussion in some other sessions. Okay. We are running out of very time. Okay.
Sir, there was a request like in maths to Subhajit sir, and he is summarizing the sessions in the one like weekly. Can we do the same in the stats too also?
Sure.
After quiz?
Sure. Okay. Let's come back. Break is over. I have given you a break which I didn't tell you. Just come back. Okay. Now let's see some properties of variance also. As I said, linearity of expectations. Here also variance has some properties where variance of a times x will be a squared of variance of x. Okay. And yeah, as you know, if I am talking about variance, I am talking about standard deviation also. It's just the square root of variance, nothing much inside it. Okay. Why we again come to standard deviation? Just because mean and standard deviation have same units. Variance has squared units. Okay. In order to have equal units for mean and variance, we just square root it and we call it as a standard deviation. Okay. And yeah, variance of x plus a will be the same variance of x. And what else? Yeah, that's it. These are the two important properties of variance. And now when x and y are two independent random variables, then we have few interesting conclusions. One is expected value of xy, x times y will be expected value of x times expected value of y. And the second one is for variance of x plus y, you can actually write it as variance of x plus variance of y. See, for variance, if x and y are not independent, you cannot split it. Linearity doesn't hold in variance unless and until both are independent. Okay. Yeah, these are some important things in variance. And I don't want to cover this covariance, correlations.
Sir,
problem
and
solving.
variance of x minus y is same as variance of x plus
x
y.
plus y. Yeah,
Okay.
this will be variance of x minus y also. Okay, if it is independent.
Again, sorry not to be intruding here, but variance of xy is again variance of x into variance of y?
No. That is not a valid conclusion. Okay, these are the only conclusions we can draw. Interesting conclusion. Okay, now let's come to very interesting, irritating inequalities. Okay, one is Markov inequality and one is Chebyshev's inequality. So what Markov tells us, if you have any random variable x with you, where x is a random variable, and if you have some finite mean, so if your mean is defined, if your expected value of x is something new, you know, it is finite also, then you can actually bound your probabilities using this inequality. So the probability that x takes values greater than or equal to c will actually be less than or equal to mu by c. So this is Markov said, and we are following it, and this is actually being true.
So this is true for both continuous and discrete.
Both continuous. This is actually true for right now. We are discussing only discrete. So this is true for discrete here, and it will be true for continuous also.
Okay.
Yeah. So what?
Again, any example that you might give as an application?
I have an example.
Okay, fine.
Okay. Let me discuss this both inequalities and we will go to the...
Sure.
Yes, sir, yes.
Okay. So this is Markov. What Markov said is, if x has some wide variation, discrete values, it is a random variable, and with finite mean, probability that x takes values greater than some value c will be less than or equal to mu by c. So this particular inequality depends on only mu, only expected value. Whereas Chebyshev's inequality, the same thing with finite mean and with finite variance also. So what this actually tells is, if I have a random variable x which is discrete with finite mean and finite variance is also something like sigma square. Okay, then what Chebyshev's inequality tells us is, this is also on probabilities only. Probability that mod x minus mu, that means probability that my random variable value takes around mu greater than or equal to some k times of standard deviation. So it may be two standard deviations or 3 standard deviations or 1 standard deviation, depending upon the k. This particular probability will be less than or equal to 1 by k square. So as simple as that. So we are finding the probability of the random variable of the values of x takes around mu outside outside k standard deviations, outside k times standard deviation. That means depending upon the k, we will get. So if k is 1, we say that my random variable takes values around mu within 1 standard deviation. Outside 1 standard deviation is actually less than or equal to 1, which is actually true. Probability will be less than or equal to 1. But when k is greater than 2 or 3, then this will be helpful. That means 3 standard deviations outside. You know this table, right? When it is continuous, when it is normal, this is 1 standard deviation, this is 2 standard deviation, this is 3 standard deviation. So this is 1 standard deviation, and this is 2 standard deviations, minus 2 sigma and plus 2 sigma. So this probability, this actual Chebyshev's inequality tells us that probability that my random variable takes outside 2 standard deviations, is taking in this regions. So taking in these regions will be less than or equal to 1 by 4. That means less than or equal to 0.25, like this. So So Chebyshev's using Chebyshev's inequality, you should know the standard deviation as well as mean. For Markov, it is enough to know
What is
mean.
A here?
Huh?
K.
Yeah, K and C you just have to find from the question.
So there are various different forms of Chebyshev, right? And we discussed that also in lecture. There are 3 or 4 different forms of Chebyshev.
See, just we are removing mod and we will make it here and there.
So sometimes it is becoming 1 minus 1 by k square.
Yeah. See, this is nothing but this is probability that x minus mu is greater than or equals to k times sigma, or x minus mu less than or equals to, so you just open the brackets.
Right, okay.
Minus k times sigma. Okay. If you open the brackets, this is the probability that x minus mu greater than or equals to k sigma, or x minus mu less than or equals to minus k sigma will be less than or equals to 1 by k square.
Okay.
Now you see, okay, this is x minus mu I have.
Yes.
Now mu you take in that. This is nothing but x is greater than or equals to mu plus k times sigma, or x is less than mu minus k times sigma. Correct? Now let's say this is mu minus k sigma, this is mu plus k sigma. So x greater than or equals to mu plus k sigma, or x less than or equals to mu minus k sigma, this probability is less than or equals to 1 by k square. That means either this side or that side, that probability will be less than or equals to 1 by k square. Okay. Then what will be the probability that is inside?
1 minus 1 by k square.
Yeah. So the probability that mu minus k sigma less than or equals to k less than or equals to mu plus k sigma will be greater than or equals to 1 minus 1 by k square. Right? If it is less than or equals to 1 by k square, this should be greater than or equals to 1 by k square. So this is one variation of it. This inside will be greater than or equals to 1 minus 1 by k square.
So the sign is also changing.
Yeah, sign will also change. And another variation is like,
sir, in this thing, what is the lower bound and upper bound, sir?
I said that why sign is changing, because it is 1 minus 1 by k square. Like if my probability of falling outside. So let me put that, if probability of falling outside is 1 by k square, right?
No,
So
less than 1 by k square. It is less than 1 by k square.
Less than 1 by k square. So the probability of falling inside will be simply 1 minus 1 by k square.
No. See, either it will be 1 by k square or it will be less than 1 by k square. If something is less than, see, if this is less than or equals to 0.2, okay, outside is less than or equals to 0.2. What will be the probability that lie inside?
Greater than 0.2. Greater than 0.2.
Greater than 0.8.
0.8, sorry.
Greater than or equal to 0.8.
Greater than or equal to 0.8, right?
Yes, sorry, greater than 0.8.
What we are doing is 1 minus 0.2. Greater than or equals to 1 minus 0.2, right? The same thing here also. If it is less than or equals to 1 by k square, here it will be greater than or equals to 1 minus 1 by k square.
Yes.
Okay. So this is one other variation, and there is another variation also. There they have actually simply taken k sigma as c. Now if this is taken as c, mod x minus mu greater than or equals to c, this will be less than or equals to, see, k, if k times sigma is c, k will be c by sigma. So this will be 1 by c by sigma whole square, and this will be sigma square by c square. Okay, this is one more variation. So everything is Chebyshev's only. Okay.
Sir, here you sir,
Can you please
here
explain
you told
why
that
Chebyshev's inequality is used?
Why Chebyshev's inequality is used to, see, sometimes we cannot actually find actual probability. Okay. Instead of calculating actual probability, what we do is we actually find an upper bound or lower bound for that particular event.
Some sort of guidance kind of thing.
Sir, can you please explain upper and lower bound here with respect to Markov and Chebyshev, please? Upper and lower bound.
Upper and lower bound. See, if it is less than or equal to, then that will be an upper bound. Okay. In your inequality, if it is less than or equal to, that means this probability will be either this or it is less than that. So the upper bound is nothing but the maximum value this probability can take. What is the maximum probability?
Mu by C.
Mu by C. So this is the upper bound. Upper bound will be mu by C. If it is greater than or equal to, then that will be a lower bound. So here, if it is here, in this case, it is greater than or equal to. So here it will be a lower 1 minus 1 by k square is the lower bound. So the probability will either be 1 minus 1 by k square or it will be higher than that. So the minimum value will be 1 minus 1 by k square. So this is lower bound. Okay.
Sir,
So it means that
Sir,
Markov find the upper bound and Chebyshev found the lower bound.
No, this particular inside, if you are computing the probability that x takes inside this mu minus k sigma,
So
then
this
you
is
will
lower
get
bound.
lower bound.
Yes.
If you are trying to compute the outside one, you will get the upper bound.
Upper bound, yes.
So if you solve this example, you will get to know.
sir, one point you said that in Chebyshev we deal with standard deviation and one more factor, and but in Markov we deal with only one factor. So what is that? Can you just repeat that?
Mean. So if you have mean, you don't need to worry about the variance and everything in order to use Markov inequality. But in Chebyshev's inequality, it is actually dependent on standard deviation, which is variance, and
Markov is always upper bound, so that much we can say. Markov is always upper. Markov is always upper bound.
Markov is always upper bound also, you cannot say. What if I ask you probability that x is taking less than c?
But in that case,
We will use Chebyshev.
It will be
Not
greater
minus.
than or equal to mu by c.
okay.
1 minus mu by c.
Hello, is the session over?
Hope not.
No, he's coming back, I guess.
I think sir has lost the
Sir को भूख
connection.
लगे.
When did the session start?
6.
Do we have session tomorrow as well?
No, not. I think no session on Sunday.
Yeah, Sunday we have session actually.
The session is from 8 to 10, right?
Yes. On Sunday.
5, right?
So generally, on which day we have sessions in week?
5, 6, 7, 8. We don't have any session.
Why they are having session on Sunday at the exam date?
And we have our submission of the assignment on that Friday. Maybe because of that, they wanted to finish it off.
That could be.
Yes, even from week 5 onward, journey is becoming tougher and tougher. What they used to tell earlier.
Yeah, Srikanth already told that the stat starts from week 7.
Yes, from week 7, and the journey is becoming tougher from week 5
Yeah,
itself.
yeah.
Hello.
Yes, sir.
Sir.
Yes, sir.
Someone kicked me out, no?
Oh my God.
Oh my God.
No?
No,
That
no,
really
no.
happened?
Huh?
You were the co-host. How we can kick you?
Maybe host. बहुत time हो गया ना.
No,
Host,
sir,
can
please
you make
continue,
me
sir. Please
co-host, please?
continue.
सर होस्ट को भी भूख लग रहा होगा ना, तो आपको किक करके खाने चला गया.
Yeah. Host, can you make me co-host? Just give me some time. I cannot share now.
Well, they are highly independent, sir.
Hmm?
They are highly independent, sir. They disconnect the session as per their wish. Time is over.
Sir, you was also the instructor of math 1.
हाँ.
I remembered you.
Thanks. अभी मैं 4 से 6 वहाँ सेशन लेके इधर आया था.
Oh my God.
So any plans to have session tomorrow also, like for week 4? That is remaining.
No, man. Tomorrow morning again I have a session of for math.
Take it in afternoon, sir. No problem, sir.
Take it in the afternoon, huh? But you guys will prepare for other subjects, na? If I take, I can take.
सर स्टैट्स निकल जाएगा, सब निकल जाएगा.
Hey, don't worry. इस बार पेपर बहुत easy है.
Okay. Sir, not for you, sir. We're talking about us.
No, not for me.
So that's true. Stats is something that is.
इतना डरा दिया ना.
Sir, we need some tips also for quiz 1 from you.
Please,
sir. For quiz 1,
Max 1
See, whatever we discuss, we are focusing on only quiz 1. Whatever Nikita discussed, me discussed, we are mainly focusing on quiz 1. So whatever we discussed, all the topics are important.
सर आप जितना पढ़ा उतने में पास हो जाएंगे ना.
क्वालिफाई होता हूँ सर, चप्पन.
सर आप जितना बताया उतना में पास हो जाएंगे ना, मैम को छोड़िए.
Sir, this binomial and this Poisson, these are haunting me actually, sir.
Okay.
So how much mock is important if we see about the in the this one?
The mock actually gives you some sort of blueprint of how your end up or quiz going to be. Okay, yeah, I got the co-host access.
So questions are similar, jumbled up or number jumbled up?
No, not number jumbling up. You see different kind of question, but the same type of question.
Pattern.
Maybe Ramesh, Suresh होगा and उधर playing होगा, इधर बैंक में invest कर दिया होगा. That is how it will be.
Okay.
Okay. But for all the subjects.
Yeah, you should identify what whatever we studied, what things need to be put into that particular question. So question is on expectation and you are doing something like join PMF and udhar बैठ के if we ask you variance and you are sitting to find mean, this is not right. If we ask you to find upper bound of Chebyshev's, you don't know how to come to use that Chebyshev's, then you will definitely face difficulty. If you know these basics, how to convert this particular data, whatever the data, real life data given to us, into what need to be find. So that is the main problem for you.
Okay.
Once you find what you have to find in the question, then it is very easy. We will give you the data set and everything. So data.
This is true for the all subjects. Math and all.
For stats too, I can, as of now we are in this session, I can talk about for this particular stats too, identifying what need to be put, what knowledge need to be put in that question is important rather than getting answers.
Okay.
Once you get that, so I have to use this step, I have to compute this, and ultimately I will get this. If you have that knowledge, enough knowledge,
we have the formulas and all.
Yeah, you will have all the formulas with you. You can use that formula, but don't make silly mistakes. So 5 by 2, don't write it like 0.4 or something. 5 by 2 is 2.5. Last, if you do some silly mistake, your entire time will get wasted. So that is why I suggest everyone, once you are done with one particular question, recheck the values, like for that PMF, marginal PMF.
And sir, these 14 questions are doable in within 1 hour.
See, these 14 questions are divided into easy, medium, and difficult. Difficult means it's not difficult. Difficult means this real life example. That's it.
Okay.
Okay.
Yes, sir,
There will be some straightforward activity questions. Okay. You don't need to worry much. So whatever you prepared, be cool. We will do.
Okay. Thanks a lot.
Yeah.
So how much you explain we will pass in that?
See, don't think about passing, Aditya. Pass तो कैसे भी हो जाएंगे. You don't need to worry about passing. If you have will to pass, you will definitely pass. You will do whatever you want to do, you will do and you will pass. But that's not our main motto or main criteria. If we are running out of time, then you think about these things. But later on, at least for quiz 1, you might think like that. But later on, quiz 2 and term, you should actually look into something you should gain from this stats too. Then only you can move. See, these things are pretty easy. When week 7 starts, na, tab start hoga, tab shuru hoga what actual statistics is.
Real game.
And that will be for intern.
This is just trials, okay?
इससे भी hard होगा sir.
Hard नहीं होगा. आप you should invest some time, think and everything. You should spend. You should sweat a lot.
फिर तो हमने 4 कोर्स ले रखा है ना, हालत खराब हो जाए.
Okay, 4 course ले रखा है, so then you might be somewhat intelligent. Okay, just use that thing.
I am not intelligent, but एज थोड़ा ज्यादा हो गया था तो मैं सोचा जल्दी कंप्लीट कर लूं.
जल्दी कंप्लीट करना. Okay, fine. Okay, not that hard. Okay, not that.
First we finish that, then we will.
Yes, sir, let us finish this. Yes.
Yeah.
Yes.
Let's come to this. Let's finish this Chebyshev inequality.
Yeah.
These are the inequality.
Okay. Hypothesis testing and all these things will come after week 7.
That is week 7, week 8. Yeah.
Okay, fine. Got it.
Okay. This is one example which uses this. First one you should use Markov. And the second one you should use Chebyshev. Okay.
So we will know that it is Markov.
We will give you.
Sir, upper bound.
Here I didn't. So X is a random variable where it gives me the number of people who booked movie tickets for a particular movie on a particular day. So expected value of X, I have given you directly, but in question it may be like the mean of this particular movie booking is 10, or on an average 10 people will book movie tickets for a particular day. See, on an average, mean, everything resembles to expectation, and with a variance of some 9. Okay, I have given you expectation, which is mu. I have given you variance, which is sigma square. What I want is find an upper bound on the probability that number of people who book movie tickets exceeds 30.
Okay. 10 by 30.
1/3.
Okay. See, and again I am telling you, upper bound means you should have inequality less than or equal to. For lower bound, you should have greater than or equal to. Okay.
Sir, just before the connection was disconnected, sir. So we were talking that we cannot generalize that for Markov it is always upper bound, right? So you took an example.
I wrote something.
Yeah, you wrote this one, sir.
Yeah, this one. See, so probability that X taking greater than or equals to C is less than or equals to mu by C, then probability that X taking less than C will be greater than or equals to 1 minus mu by C.
Yes, so it becomes lower bound, right?
Now here it will become lower bound.
Yes, so we cannot generalize for Markov.
See, here the same question I can ask you reversely. Find a lower bound on the probability that number of people who booked movie tickets will not go below 10. Something like that. So then the question is like, will not go below 10. What is C here? I said you 30. Use Markov. 30. Correct.
Sir, can you repeat? I just got confused what you said.
I'm just confused on CBCS.
Okay, let us do this thing. I will tell you other thing also.
I was not able to solve a single question in CBCS.
First solve Markov, no? Then.
Yeah, I can do the markup, sir. I had solved the question.
Markov, okay.
Yeah.
What is the Markov inequality? Tells us probability that x greater than or equal to c will be less than or equal to mu by c. So you just have to identify what is c, what is mu. That's it.
Yeah.
So what is
Very
c?
easy.
What is c?
C is 30.
30.
And,
what is
mu is 10.
Mu is 10. So probability that x exceeds 30, that means x greater than or equal to 30 is less than or equal to 10 by 30, which is actually 1 by 3, right? So I need an upper bound. Upper bound means maximum value of this probability. So maximum value will be 1 by 3. Correct? Now the question can be like
that. What were you talking about this lower bound in this case?
In this case, yeah, I'm about to tell that. Now my question is, find an lower bound on the probability that number of people who book movie tickets will not go below 20.
It's the same, sir. I think.
Same. Will not go below 20 means I need the probability that
more than 20.
Will not. Oh,
X.
Will go below 20. Will not exceed.
It means the x less than 20.
Yeah, will not exceed 20. That means x less than 20 I need. Probability that x is less than 20. So how do I get this probability that x is less than 20? Up, lower bound. So we know
1 minus x greater than or equal to 20.
We know probability that x greater than or equals to 20.
Yes.
This is less than or equal to 10 by 20, which is half. So if the probability that x is greater than 20 is half, less than or equals to half, what is the probability that x is less than 20?
Half.
It is greater than or equals to 1 minus half, okay, which is half.
Sir, just taking a reference from one of the activity question, there is a doubt here because it's sir, be here, sir, be here only, be here.
Okay.
The first case when it is talking about exceeds 30, right? So in that case we had taken 31, not 30, because it's a discrete random variable. So we had taken 31. We had not taken 30. People who had done 30, so it was reflecting wrong answer. So in one of the live sessions,
Okay, exceeds 30. Okay.
So in one of the live session, it was clarified that it should be 31, 10 by 31.
Correct. Exceeds 30 means, yeah. So this is 10 by 31. Okay, why change this? Why to spoil everyone? X is 29.
Yes.
Okay.
Yes. So now it will be 10 by 30.
Okay. 10 by 30, 1 by 3. Okay. Will not exceed 20.
29.
This is okay.
Yes. Will not exceed 20. Yes.
Will not exceed 20 is okay. Probability that x is exceed 20, x less than or equals to 20. I said.
Yes.
Right.
Yes.
So that number, can you please repeat again? The 30 and 29. So can you just repeat that number again, please?
See, this actually falls under English words. Exceeds means it should be greater than 29. So 29, it cannot take 29 here. Okay. So greater than 29, that means greater than 30, that means 30, 31, 32, like that. So probability that x greater than or equals to 30 will be less than or equals to 1 by 30. Okay. So in the lower bound case, what is this? It's just the opposite. You don't need to do anything. It's just the opposite. If x is greater, if this is c, we know that probability that x greater than or equals to c is less than, this is less than or equals to mu by c. Then this particular x less than c, this will be greater than or equals to 1 minus mu by c. That's it. Because the whole probability should be 1. 1 is less than or equals to mu by c. Other one will be greater than or equals to 1 minus mu by c. So here this is x greater than or equals to c. Here this is x less than c. That is what. Just convert the English statement into this inequalities. So exceeds means greater than or equal to. Will not exceed means less than or equal.
So, sir, whatever value will be given, so value of C, we will be taking adding 1 to that. Whatever value will be given in the question, we will be adding 1 to that, and that will take the value of C.
Exceeds, if we have given exceeds, or greater than or equals to 30 also can be. Who booked movies tickets greater than or equals to 30. So greater than or equal to 30. That is direct word. Okay. So that is what it changes. Now you see, you find this. Find a lower bound. Lower bound. See the lower bound on the probability that number of people who booked movie tickets will be in between 2 and 18. So what probability I need to find? Probability that
1 minus 1 by K.
correct?
Yes, sir.
So for this probability, I need to find the lower bound. Lower bound means this is greater than or equal. I need to get greater than or equal to something.
1 minus 1 by K is correct, sir?
1
minus 1 by K is correct.
What is K?
K will be 4, sir. No, sorry, sir. Let me find out. Sorry.
2.66.
Yes, correct. Sorry.
K will be 4.
No, not 4, sir.
No,
Sigma
sir,
is 3.
2.66.
Yes, 2.66.
Oh, I gave it like this. Okay, I don't want to give like that. See, in between, lies in between 2 and 18 is something like 2 and 18 is something like 3 less than or equals to 17. Okay. Anyway. K is 2.
So will it have equals to? Because it's between.
Now it comes to 0.8590.
Okay. 3. Okay, I need this. Okay. 17 minus 3, 4. See, in between. So what is in between 1 and 4? 2 and 3 only, right? Do we include 1 and 4 also in between thing?
No. Defined, sir. That is being defined separately. Endpoints included, endpoint not included, something like that.
We are talking about between, in between.
Between means included. Correct. Not included.
Means not included. Not
Yes.
included. Yeah. Now we have to find the probability of that x is greater than or equals to 4
and 16.
And 16. Man. Even I am confusing with this less than or equal to things. This is 4 and 16. Okay. Now it should be in between 4 and 16. Correct? What we know is from Chebyshev's inequality, we know that probability that mod x minus 10 greater than or equals to k times what is sigma 3. Right? We have given variance as 9, so sigma will be 3. This will be less than or equals to
1 by K square.
1 upon K square.
1 upon K square. But we require this thing, probability that x is in between 4 and 16. So now you see, if we open this, we know that this thing, right? Probability that mu minus K sigma less than x less than mu plus K sigma will be greater than or equal to 1 by 1 minus 1 by k square. Okay, we are just computing in between problem.
Just now it's yes.
Yes, sir. Now we got k is equal to
Yes, now k is
2, right? Now k is 2. Okay, now see mu minus k sigma is 4, mu plus k sigma is 16. From here you can get the value of k, and the value of k will be 2.
Yes.
Well, once you get the value of k is equal to 2, this will be 1 minus 1 by 2 square. So this will be 1 minus 0.25, which is greater than
3 by 4, 0.75.
So that means the lower bound will be 0.75. Okay.
Yes.
So this is about Chebyshev's Markov.
Also, at least and at most it is at least 3 by 4.
I have a question
At
here.
least 3 by 4, yeah.
I have a question here. When you were explaining the inequalities above, it was actually written as greater than or equal to k sigma. Now it is probability of x greater than 4 and less than 16. So how did this equal to the inequality part of it go away?
Inequality part is there, right?
No, I mean to say within the probability that you're actually
equality. So this is actually, here it is actually equal to k sigma. Here in this itself, it takes value mu plus k sigma and mu minus k sigma inside this probability. If I am looking at the complement of this, here it won't come. Here the inequality will go off. See, here here you see x is greater than or equal to mu plus k sigma. And x is.
Where are you pointing to, please? I'm not really able to see you.
You are not able to?
I'm not able to see what you're pointing at actually.
Here.
Okay. All right.
Okay. This Chebyshev's inequality is this, right? If I open this, we will get probability that x greater than or equal to mu plus k sigma, or x is less than or equal to mu minus k sigma is less than or equal to 1 by k square. That means this mu plus k sigma and this mu minus k sigma are included in this probability, goes into this region. If I see the complement of it, which is inside of it, inside of it will be only strictly inside. Okay.
Okay. Got it.
So in that problem, how did we get k equals to 2 further down between 4 and 16?
Here we know mu and sigma.
Yes.
What is mu? Mu is 10 minus k times sigma is 3.
Equals to 4.
So from here, 10 minus k times 3 is equals to 4. We get k times 3 is equals to 6. K is equals to 2.
Okay, sir.
Okay. Even if you use this also, you'll get k is equal to 2.
Yes, I got it.
Okay.
Thank you.
So these are about the week 1, week 2, week 3. Okay. So what are other things left in week 4?
Sir, I had asked you before moving to week 4, I had asked you one question on conditional
Which
probability.
question is that?
That x1, x2, and x3 are IID samples.
Correct.
Yeah, that question.
Okay, let us see that thing also.
Sir, I'm not able to solve that conditional thing, like how to go about it actually. So could you help me, please? Yeah, Bernoulli 1 by 3 samples.
Okay. Now there is a new random variable.
Find the y is equal to x1 plus x2 plus so on up to x10. I need help in conditions. Sir. Probability of x1 is equal to a1, conditioned y is equal to 8. Yeah, this is my question.
Okay. For this, we need to find two things. X1 is equal to 1 and y is equal to 8, and probability that y is equal to 8. Correct? So what is the probability that y is equal to 8? So what is y follows?
Binomial 10.
Binomial 10, 1 by 3.
If it is following binomial 10, 1 by 3, what is the probability that y takes 8?
10 choose 8, 1 by 3 to the power 8, 2 by 3 to the power square. Yes, sir. This I understood. Sir.
Understood.
The numerator part actually I'm facing difficulties.
Yeah, numerator part is like joint PMF between x1 and y. Okay. Now I need the value of y taking 8, and also at the same time x1 takes 1. So that means x1 is taking 1, and other 9 values, out of other 9 values, I need to have 7 ones. Correct?
Yes, sir.
Yes, sir.
This is the combination, right? So 1, 0, some 2 zeros and all other should be 1. Or these 2 zeros can be placed these 2 zeros can be taken by any random variable from x2 to x10.
So 10C2, sir, this kind of thing?
It's not 10C2.
It is 9C, isn't it?
So can we write the numerator as
9C7.
Yeah,
probability of y is equal to 8 given x1 equal to 1 times probability of x1 equals 1.
Probability of y given 8 given x1 is equals to 1 times probability that x1 is equals to 1.
Does this make it easier?
Right. Correct. Now you see, given, correct, thanks. So x1 is given 1 now. Okay. If x1 I substitute 1, y should take value 8. So that means this sum should take value 7. Now ultimately this whole thing converts to x2 plus and so on x10 takes value 7. Okay. This thing follows binomial 9 comma 1 by 3. Getting the point?
Yes.
See, here it is
Yes,
given
sir,
that
understood.
x1 is equals to 1. Okay. What is the probability that y takes value 8? So it is same as probability that x2 plus x3 plus and so on x10 takes value 7. So this particular conditional probability is nothing but this thing. Right?
Yes, sir.
Then probability of x1 equal to half, right?
Probability of x1 is equal to, this is half.
1 by 3, right?
Oh, correct, 1 by 3.
That is 1 by 3. Huh?
And this one is again binomial. This is again binomial 9 comma 1 by 3. So this is 9 choose 7 times 1 by 3 whole power 7, 2 by 3 whole power 2 into 1 by 3 divided by 10 choose 8, 1 by 3 whole power 8, 2 by 3 whole power 2. This is simply equal to 9 choose 7 divided by 10 choose 8. 9 into 8 by...
There's a 1 by 3 missing, I think. You need a 1 by 3 as well.
That got cancelled.
On the denominator side.
That will be cancelled, right?
On the numerator, you have 1 by 3 power 7. Denominator, you have 1 by 3 power 8.
Here we will get 1 by 3 also. Again 1 by 3 for probability that x1 is equal to.
Yeah, that's what I meant.
So I am getting 4 by 5, which is 0.8. Is this correct?
Therein lies the problem.
Can you check the answer?
Sir?
What is the answer given?
Check the answer.
Yeah,
No,
I think she probably lost her connection.
Oh.
Sir?
In
the meantime, if we go through the earlier methodology which we were explaining, like joint distribution, probability of in this question only, in this question, taking probability of x1 equal to 1, intersection of probability of y equal to 8, right? So through that route, how will we solve?
See, that again you convert into conditional.
So there is a small problem with the cancellation that has happened. The numerator you have 1 by 3 power 7, and the denominator you have 1 by 3 power 8. So there will be a 1 by 3 left out, which actually flips up and goes up. So it will be 4 by 5 into 3.
Then the probability is going above 1, right?
It's exceeding 1.
No. See, it's 1 by 3 power 7, and there is another thing.
1 by 3.
Probability that x1 is equals to 1. Taking x1 is equals to 1. That will be 1 by 3 here. Even the numerator has 1 by 3 power 8.
Sorry, I missed that part. Why is that?
See, this particular x1 is equals to 1, y is equals to 8. I can write it as probability that y is equals to 8 given x1 is equals to 1 times probability that x1 is equals to 1.
Okay. Yeah.
Okay. So now this conditional distribution can be simplified like this: x2 plus x3 plus and so on x10 is equals to 7. And again, there will be probability of x1 is equals to 1 in the product. Okay. Okay, I think 0.8 is correct. Okay, this is about week 1, week 2, week 3 most important topics. So just go back, go through this, solve few problems related to these topics. And yeah, week 4 we discussed till
So CDF we have discussed.
CDF we have discussed. Let me get the PDF
Discrete.
from
For discrete we have discussed.
Okay.
And continuous also. So for discrete PMF and for continuous PDF.
What is this? It is not downloading. Okay, let me stop this one. Okay, is my screen visible now? The new screen.
Yes, sir.
Okay. Now, I think 1.4, 1.5, this. Actions, properties. Just common distributions, is it?
Yes, sir. We had to.
Okay.
The distributions were left for discussion.
These are the distributions, right? Common distributions.
Yes, sir.
Okay. I think not much left. Okay. So these are just the PDFs of some common distributions which actually taught in the lectures. What the... So what to do? Let me just check. Okay, this is like a line-to-line explanation only. I guess once this PDF is shared, it is very easier for you guys to go through this. It's just like common distributions, the PDF of the common distribution along with CDF and some example. Like whatever the professor did in the lecture itself, we have given you. So how to find that? Every solution is given to you. I don't think I need to put pen on this. Just the calculations. So we all know these PDF and CDFs we will give you. So common distributions of uniform distribution will give you. Exponential distribution, PDF, CDF we will give you. You just have to know how to find the probabilities of these like this. If the probability asks like -3 less than or equals to x less than or equals to 2, how you find? Okay, like this kind of things. Do I need to explain all this? Exponential, normal. Okay, let me take one distribution and I will explain with an example. And you try for other things. See, in detail solutions have been given. I don't think much explanation is needed from our side. So give me one distribution which you feel difficult in continuous distributions.
The exponential and normal.
Exponential and normal. Okay, let me take exponential. Normal. Okay, normal and exponential. Okay, let me see. Let me start with exponential. See, the graphs of exponential. If x is exponentially distributed, with lambda parameter lambda. This is how the PDFs will be. After some value, it will have an huge probability of success, probability of that particular random variable taking those values will be high, and later on it will exponentially decrease. So you can see it on the PDF. And right side one is just the CDF. It starts from 0 and it goes to 1. And the PDF and CDF of these exponential functions are given like this, where f of x is lambda times e to the power minus lambda x, where x is greater than 0, and if x is less than 0, it will be 0. So when the random variable is taking only positive values, then you should identify that that particular random variable follows exponential distribution or chi-square distribution, which not came yet. So as of now, if your random variable is taking positive values, then 99% it follows exponential distribution. Okay, the PDF, and if you integrate the PDF, you will get the CDF, which is the below one, capital F of x. 0 if it is x less than or equals to 0, and 1 minus e power minus lambda x when x is greater than 0. Okay. Yeah, these are pretty elementary proofs. You can just check. You just have to check integral from minus infinity to infinity, or you should actually check within the given support of x, the integration should be equal to 1. So there are some remarks in case of uniform support is
Sir, can you please elaborate the support? What is the basic?
See, support is actually the range. In discrete we have range, right? Here support means in which region actually the probability is positive. Okay. So we only take that particular region. So that is called support. Support, range, both are same. Range we use for discrete, support here we use for continuous.
Okay, clear.
Okay, yeah. So, one thing, I'm not a good fan of reading textbooks. I like to write my own notes and I like to explain on that my notes. But anyway, see, this is what PDF and CDF of it. We will give you the PDF and CDF, but you should know how to compute the probabilities. So here you see it is given that x follows exponential with parameter 2. We need to find the probability that x takes values between 5 and 7, first value. So as this is continuous, what you have to do is you should have to integrate from 5 to 7. Inside you should keep fx, which is PDF, and you have to integrate it. So if you write the PDF of x, that will be 2 times e to the power minus 2x. Correct? So 5 to 7, 2 times e to the power minus 2x. Use some calculus. Even we will give this calculus integrations as an hint. So if you do so, you will get this.
So then we can solve it taking the help of CDF formula 1 minus e to the power minus lambda x, right?
Yeah, 1 minus.
So it will be 7 minus 5 is
fx of 7 minus
fx of 5, right?
fx of 5. Correct. Even you can use that method.
A question. When we are given the PDF, integrating that, we get the probability, right?
Integrating that will give you the if you integrate within a region.
Within a region, that is, I'll get the probability.
Of that region.
Exactly. And then if you have to go to the CDF, then we integrate that again.
No. CDF, you no need to integrate. If you integrate PDF, you will get CDF then. If you integrate CDF, you will get something like KGF.
Oh, okay.
Definition of CDF.
Okay, PDF, if you integrate, you will get CDF. CDF, if you differentiate, you will get PDF. Okay. You don't need to integrate. There is no integration of CDF. And even if you integrate, you won't get any further conclusions or further valid statistical terms. You are going
So, no, I'm saying about integrating the probability that after we integrate the PDF, we're getting the probability for that region, right? Now, from the probability of that region, we have to, like, going to get the CDF, then we have to integrate it or not?
No.
No, sir.
No.
From PDF to CDF, we have to differentiate it.
From CDF to PDF, we have to differentiate.
From CDF to PDF, you have to differentiate.
So, from PDF to CDF, like, we just do one integration and we get the probability, right? We are not getting the CDF.
You are not getting, that is the CDF, right?
Sir,
The
that is a
of
CDF
in
only.
that
5 to
particular
7. In this example itself, if we take 5 to 7, it means this is the probability in this range from 5 to 7. So this range is nothing but the CDF of this range only, no? 5 to 7.
See, if you integrate, you will get the probability. That probability is shown in CDFs. Okay.
Okay.
Here you see that jumps you see. Is my cursor visible?
Yes.
Here, see, here there is a large jump within this shorter range, right? So the values of X occurring within this shorter range has higher probability is what this CDF gives you. This particular value here, gives you the probability of X less than this thing. CDF, you know, right? P of X less than or equals to some C.
Yes.
CDF.
Yes, got that.
CDF. So probability that X taking value less than or equals to X will be the CDF. So if you touch here, if you see here the value, the value here, that is the probability that X takes value less than or equals to this particular point. Yes. But if you see in the regions, from here to here, if you wanted to see the probability of X lying in between these regions, what you have to do is you have to take this probability, you have to subtract from this probability, you will get the probability that X takes within this region. So that is what we've done.
So it's basically the difference of two CDFs, right?
Difference of two CDFs. Correct.
Got it. Thank you.
Sir, if the PDF is given, we have to integrate it and find the, according to our limits, find the probability.
Correct. That is one way. If you know CDF, if the probability that 5 less than X less than 7 can be written as capital F X of 7 minus capital F X of 5. Okay, it's just the subtraction of two CDFs.
Yes, sir. Yes. Oh, understood.
Okay. So what we do is we subtract probability that X less than or equals to 5 from X less than or equals to 7. You get the region of 5 to 7.
Okay, direct in the equation.
Yeah. If you know CDF, you can do like that. If you don't know CDF, you just have to integrate the PDF.
Okay.
Yeah, that's it. I guess. See, once we share this PDF, you can go each step by step and you will get to know. Okay.
So this both PDF will be shared?
Yeah, both PDFs we will share with you. Okay, that's it from my side.
Thank you very much, sir.
Sir, you parked couple of
Where are you?
When are you?
So this PDF will be supplemented into conference, right?
That you will get an announcement. You don't worry. Wherever we posted.
Sir, please post this like this PDF.
Yeah, of course.
Sir, you have parked couple of questions, sir, which we asked at the beginning. Then you said I will explain it later. Towards the end.
What questions are that?
These are very simple questions, sir. Like for two random variables, sir, X and Y, sir, we presented the joint probability in a very nice tabular format, right? So in case, say for example, if there are 3 or 4 random variables, then I think getting that kind of nice.
Don't go there. Okay, utna mat soch abhi ke liye. If after quiz, after quiz we will have one session.
I am eagerly waiting for that session, sir, because there are many questions which are getting parked.
Yes, sir. Sir, will we? taking sessions for week 5, 6, 7.
Yeah, from week 5, 6, 7, I will continuously take one for each week.
Okay, that will be great,
Sir,
sir.
Okay.
if time permits, sir, could you explain the concept of conditioning and factors of the joint
Definitely,
theorem,
even
sir?
I am interested to take one general live session, which
Yes, we have so many questions left.
yeah, so many
One
questions.
will not help, sir. So many questions have been parked. Nikita ma'am has said so many questions. Okay, we'll discuss later on. We'll discuss later on.
Okay, we will do one thing then. After exam, I will schedule a session around some. When is your next session?
Next session is Sunday, sir.
On Sunday, sir.
There is a
Sunday
small
evening.
request, sir. Can you schedule it on Monday, sir? Because Sunday we have exam and many people have to
Sunday
travel a
evening?
lot, sir. Many people have to travel a lot, sir. So I don't know whether the second slot people will able to reach on time or not.
Sir, we'll reach around 8 o'clock, sir.
Yeah, Sunday evening.
One session for the summarization of the week.
So Monday, sir,
Like-
we can have Monday and Tuesday, sir.
No, seriously, Sunday session is going to be quite tricky because I have to
Yeah,
travel
see,
2.5 hours.
someone is writing that he has to travel 4 hours, sir.
Okay.
2.5 hours at least.
Sir?
I have to.
Okay, we will.
Sir, you told that you will take one session that you will summarize the whole week. That you are going to take.
Most
Please
probably
take-
me only. It's like an on-demand session kind of thing.
Please you take, sir.
So this we have
Yes,
requested.
sir. Please.
Why
This we have requested.
It's a request.
So this we have
Yes, sir.
requested several times, sir.
Because
Out of 3
because
sessions,
we
one
are
can be
habitual
dedicated.
from you from math 1.
Okay.
One session can be dedicated for summarization, sir. Like out of 3 sessions, sir. Every week we can dedicate one session for summarization, sir. This we have.
अगले week से होने वाला है. I am going to summarize each
You
and
can
every.
take session on Sunday, sir. So that's the right time, so that you know.
Okay, we will.
I have a question on the conditioning that you had shown earlier during this Bernoulli problem, which the lady asked. It was basically probability of x is equal to 1 given, x is equal to 1 given y is equal to 8. You flip it around with probability of y is equal to 8 given x is equal to 1 into probability of x is equal to 1. Is that a formula like?
No, it's just the conditional distribution to join, right? We just converted it. We just played around join, conditional, and marginal. This thing, right? You are asking this thing.
Yes. Can you?
This is actually the joint, which is equal to conditional times marginal.
Okay. Thank you.
Yeah.
Thank you.
Sir,
I'll break my head about it.
Sir, can we expect rescheduling of Sunday session to Monday, sir? Is it possible? Please do it, sir.
Most probably we will do. I don't think it is actually पहले schedule कर दिया होगा. अभी change नहीं किया
Doesn't
होगा.
make sense, sir. Please have it on Monday.
In case if you're having it on Monday, sir, can we request it to have it from 8 p.m., sir, please?
Sunday कब है?
Sunday 8 से, sir.
8 से. Then it will be on 8 only. If it postponed to Monday. Okay.
Just remove the if, please. It's really, I live in a metro, but it is still not practical. My house is on one side, the center is on the other side.
Of course. We will look into it. You don't worry.
Yeah.
We are student friendly. Okay.
Thank you, sir.
And will you be taking a session on Stats 2 tomorrow?
Stats 2 चाहिए?
I don't know. There was some discussion of having a session tomorrow.
Yes, sir, if possible tomorrow.
Also, I think this
Yes, sir. Can you please conduct another session tomorrow for like an hour only, if possible?
You are asking for 1 hour. Will you guarantee that 1 hour में खत्म हो जाएगा?
Yes,
No,
sir.
sir,
Just
we are
last
hoping
minute
that you will
revision
agree
and
for 1
some
hour.
quick doubts.
Okay. Is it like definitely necessary? See, the thing is, tomorrow also I have a session for Max 1. Okay. वो complete करके फिर से आपके पास आना है. Just like today what I did. I think मैंने जो कुछ बोलना है वो बोल चुका हूँ. Whatever I wanted to discuss with regards to quiz 1. Okay. Oh, prepare that well enough. छोटा doubts है वो. Okay, I will try. Okay, I will ask studio team to adjust one session maybe. See, my problem is अगर आप कल भी statistics पढ़ोगे, बाकी subjects कब पढ़ोगे?
Exam के बाद.
Exam के बाद. When will you study other subjects? Just give some enough time to each and every subject. Na? Just chillax. Whatever you did, just study for 2 or 3 hours of statistics subject again. Just go back to this PDF ऐसा ही just have a glance about it. Just go through the problems the topics which we discussed. Just open graded or activity or whatever. Just try to solve those problems again. That is enough, man. That is enough. Don't
Can you
worry
repeat,
a
sir?
lot. Okay. Whatever
So if
we
we follow
discuss
this,
if you
we follow
follow
this strategy, then I think we are able to easily crack.
Wait, can you repeat, sir? Can you
No
repeat
problem.
once?
So what I have to repeat is, if you follow these PDFs well enough, if you solve the problems which we discussed, I think most of the topics I covered. One
Yes,
or
sir.
two, leaving
Yes.
1, 2, 3 topics. Most important topics I covered, and with examples I have covered. So go through the examples PDF and again the examples in activity and graded which related to these topics. It is sufficient. So spend some 2-3 hours of time, solid 2-3 hours. It's not like you are eating and sleeping on the bed and reading statistics. ऐसा नहीं चलेगा. You should sit for solid 2 hours, dedicate 2-3 hours for statistics too tomorrow, and it is enough. I don't think extra session required. So that is why we are having Monday, right? Monday session में जो भी आप सीखना है, we will learn in that session.
Monday will be dedicated for week 5, no, sir. No.
No. I'm not saying week 5. Monday session is dedicated to what all doubts are postponed to next week's. बोला था ना आपने. सब आगे
वो तो week